100% infill. Huge thing here. This is also on Nylon. I mean, can you even see it 3D printed? Oh no, even play around. It's very nice. So we are in the lab. 40mm tube. Whoa. Be mine. All our different materials. How do you guys like this? I think we are live. Hey everyone, how is it going? FDAF patch, non-farm, 3D Medic Beans. Thank you everyone for joining. Mark Andraka, Francis Bellon, Nathan is coming, Michael Wingington, hello. Buildersmark, you switch streams so fast, Buildersmark. We were, I don't know how many of you, but just before I was on Twitch watching microscopic views of our filaments, and it was pretty nice. Actually, you know, we have for Polytera, we have a very specific formula, and then under the microscope, she was actually seeing, you know, the stuff we are doing with Polytera, and then she was like, you know, oh, that's interesting. You have this, and then I was like, oh my God, I know exactly, you know, all of these different stuff, but you know, I cannot say what is in the formula. But it's interesting to see an engineer diving into, you know, the microscopic view and making some hypothesis about, you know, what could be inside the filament. So it was pretty amazing. And then some other filament, like we were saying stuff, and even though I know, you know, what is in the filament, and then, you know, the formula, I had no idea what was in the filament. Like for example, for sparkles, you had like some kind of, like all the sparkles was like kind of gathering in the middle or something. So a lot of things I had no idea. So actually we are going to receive all the pictures, the microscopic views, and then we're going to check the slide with the R&D, and then try to trigger some discussion. But very interesting stream that we were watching just before the stream. Oh, Michael was there. Nice. I think Buildersmark and Michael is the name I recognize, but maybe some other that has a different name on Twitch. I miss Pink stream. Very interesting. Yeah, it was very interesting. So let's get our usual giveaway started. I am awesome. Let's start first by bringing some awesomeness to this live stream, and then let me put the banner up. Great. Yeah, the sparkle line. Oh, you were there as well, kids? Yeah, that was interesting. I'm wondering if it has to do with you know, the flow of the material in our extruder line, and somehow kind of got like pushing all the glitters in the middle, or because there were glitter on the side as well, but they were cut. So, you know, it could be the orientation of the sparkles. I don't know. But anyway, that could be another interesting print buster topic. You know, like we get into the microscopic views of different filament, and then we kind of explain what's going on. It could help us to understand more 3D printing phenomenon at the end of the day. I'm so sleepy right now. Ooh, we are going to talk about science, so that's not going to help. Art March Animation. Thank you for joining as well. Rose Apple Media on Twitch. Okay, got it. Yeah, I wish all the platform has the same username. It would make things so much easier. Stop the count. What? Oh, wait. Actually, you know what? There's one thing is, I don't know if you were talking about this, but I have my Discord that keep making noise, and I have no idea where it come from. Like, you know, I thought the noise was only when you get notified. like when someone ping you or something, and somehow nobody pings me, but I keep hearing like did it. So let me just I don't know how can I how if I can mute the whole Discord just for now. Let me check. I forgot to check that just before. Can you hear? Can you hear all the did it notification, message, disable all notifications on, message? Okay, so let me disable everything. Okay, there you go. Oh, okay, I disable everything. That should be now you have the teams that is, and let me close my team. There you go. Because I just communicated. I just took some screenshot and sent to R&D. So on Teams, and then we started talking a little bit about what's going on in these filaments. We hear it. Yeah, that should be fine now. I just muted the Discord. It's not that could be a server that's got all messages turned on, which is annoying to me. Yeah, I need to find that server because I'm in a couple of them, and then I will try to find it. Should I enter the giveaway? That's the question. Yeah, you should. You can win more and more and more and more. Well, as long as you're awesome, right? Okay, guys. So today, there's two things. The first one is I went print busting in some Facebook group. What does print busting means? I went on some Facebook group and then I kickstarted some discussion. But you know the kind of discussion that I was like, hey guys, do you know what is warping? Or like, do you know where warping come from? And then they started explaining, and then I go through, the usual thing of, oh, okay, interesting. So why if they have the same coefficient of thermal expansion, then this happened? And then, so why if I'm cooling more, then this happened? So, I started print busting on many, many different groups. And I want we check together some of the answers. There is, why I'm doing this for two reasons. The first reason is I want to push more people from the 3D printing community to think more about, what is happening. Not, I don't want to force people to understand what's happening. What I want is the people that are coming to answer are the people that, like to have the knowledge or think that they have the knowledge and then come and help. And I want to, in exchange of them coming to help, then I want to bring more knowledge and then hopefully create that synergy. Because sometimes, there, like we said before, you had some people that want to solve problems. They don't care about what's happening. They just want to solve problems. So that's fine. And then you have some people that come with, a lot of strange explanation. And that's the people that I want to target. Because for one reason, I think we can improve this explanation. And second, they usually have very good point. Like sometimes it's not very structured in the explanation, but they have some particular point that I've never thought before, and that allow us to have some new ways of thinking about warping. There is two particular points that has raised during this discussion that I haven't thought before, and I thought that was very smart. They brought it in a slightly different way, but if you reshape their explanation, it could actually make sense for our print buster work. So that's what I call print busting. So if there is some of you that would like to print bust with me, that's the new word. If you would like to print bust with me, then do the same. Go on some group and start poking people, that are talking about stuff, and start challenging people around. Like start being annoying like I am. That's the only way we can learn more about 3D printing. But let me go straight into that and then show you what I've been doing. So I've been print busting on the 3D printing group, this one. So it has 150,000 members. Oh, you know what? I forgot. I should have print busting on Reddit as well. Maybe for the next episode. And then on 3D printing O's. And then this 3D printing group, which is another one with the same name, but this one has 100,000 members. And then on Prusa 3D printing, of course. I think the Prusa community is how to say, usually the Prusa community are a little bit more active, like to dive a little bit more, like a little bit deeper into stuff, I've noticed. So I like to go in Prusa communities to talk about 3D printing stuff. Like, for example, if you compare the Ender 3 user group on Facebook and the Prusa group, there is quite a difference into like the topics they are talking about, and then the level they are going into. So I prefer the Prusa group, even though the Ender 3 user group on Facebook is much bigger. And then I've been on 3D Printing Geeks and 3D Printing Canada. There is also an interesting group. So warping is called by bed gnomes. Well, you're going to see, John, you're going to see that most of the answers are almost the same. It's like, we start discussing, they start laying down, what everyone say about warping. And then once you start asking question, it goes usually three ways. Either when you ask question, they just say, this is how it is. Like, for example, why some material warps more than other? And then the answer is because they're different. But, that doesn't help. What's the difference? And then they say, but we cannot know. That's just how, the material are different. Some are warping more than other. But that doesn't really answer the question, right? So the first way of going is, this is how it is. The second way is, they just tell you, why do you care? Why do you care? I just told you how to solve your warping issue. Why do you care about how it works? So that's the second way it goes. And the third way is, I don't know, basically. So, but you're going to see that sometime, and how social media goes, right? Sometimes it goes in a very interesting way, the discussion. And that's the thing a little bit with social media, right? Somehow, if you're print busting, it often end up on how to say, like less how to say, like a little bit of a heated discussion, just because you are challenging a little bit what they're saying. Then it goes directly into a little bit of a confrontation on the comment, which I'm used to. People don't like that. You're asking why to their answer, but that's that's how it is, right? You cannot if you say something, then and someone is challenging you, then you have to be cool about it, right? It's normal if someone wants to understand more and don't want just listening to what you're saying. So you're going to see that sometimes the discussion is not really going into a very constructive way. So that's why sometimes I just I just don't answer. Or sometimes I answer some funny stuff, which you're going to see. Let me catch up a little bit on that. You have to talk to a material engineer, someone like Stefan from CNC Kitchen. I'm not too sure Stefan would be very helpful with that part. I think on the hardware side, on the more engineering, like Stefan would be exactly like me. He would also find the right question, but I don't think he has the answers to this question. But we can definitely invite Stefan on stream to see. But I've been watching a lot of his video. I've been following his Twitter, of course, and I've been following some of the answers he put on his comments. And I can feel that it might not be, I don't think he will have the answers, but I would be interested to see if he would be interested in finding out answers. And I think that would be the great thing about Stefan, is that he's very curious. So if you put him on something that he doesn't know, then he's going to he's going to dive into that, and then he's going to design perfect testing for that. So that's the great part about CNC Kitchen. A Twitter hashtag sounds pretty good. I want to believe we can get it trending. Yeah, print busters, print busting, print bust some stuff, like you write something asking about something, and then someone is explaining, and then you just answer him, yeah, sorry for being a print busters, but how do you know blah blah blah, or how would you explain blah blah blah. Knowledge is awesome. I completely agree. I won some Mobots YouTube stream 3 weeks ago. It didn't arrive. Sim Hoffman, contact me on my email, my Discord, on Twitter, or just PM me, and then we can check that. There are small glows that live on the bed. You have to kill them with isopropyl. It gets them drunk, and the warping stopped for a while. I wish, John, that was that easy. Did I catch up everything? Yes. Okay, so let's start with the first one. So the first one, by the way, all the pictures that I use are just a Google picture, just because somehow the post with the pictures is working better than without pictures. So I just put a pictures of something warping. So the first thing is, and you are going to see also how people answer. Like first, yeah, anyway, let's just see. If warping was caused by thermal expansion and shrinkage, then why polycarbonate warps more than PLA? Okay, so it's a pretty open question, right? It can be answered in many different ways. Or so let's see what people answer to that. So I think that's the post that got the least amount of answers. But let's see. So there's this guy that so he sent me a screenshot of stuff. So enclosed build chamber, bed adhesion, blah blah blah. So how to solve warping basically. Which was not my question. And then how to print with polycarbonate. So basically a screenshot of stuff that are not very useful. And then I say, thank you for sharing, but it doesn't answer my question. Actually, not at all. And then the explanation is that polycarbonate requires a really, really hot printing in an enclosure to print filament that requires really, really hot printing in an enclosure to prevent warping. I'm not an expert. I'm just extrapolating here. But being that it's a type of carbonate, it probably needs those specific requirements for the appropriate crystalline structures to form and set correctly. Without that, it cools too quickly and is prone to warping as the molecules are not set in the appropriate structure for proper shape and rigidity. You can technically bring PLA up to special temperature in an oven to harden it. Yeah, so again, first, it doesn't answer the question. We are talking about the difference between polycarbonate and PLA, and then he's talking about the fact that PC requires a heated chamber to not warp. And then he's talking about crystalline structure, blah, blah, blah. But, I know, not everybody is an expert in material science, and not everybody knows that PC, for example, is amorphous and PLA is not amorphous. So he's talking about crystalline in PC, which doesn't exist, right? But that's fine. So what I'm saying is, got it. However, PC is amorphous, so most likely it will not crystallize. And then I just say that there is no more research, blah blah blah. And then doing more reading on it, I was definitely wrong, but it probably comes down to what specific chemicals are used and how they react to sudden temperature change while moldable. PC doesn't apparently have specific recipes, so it's entirely possible that some might warp less than other. So that's one of the way that I explained at the beginning. The way it ended up here is that's how it is. Some material are chemically different than other materials, so some warp than other. So that's one of the way I told you that the discussion is ending up. And often it's going to end up like this. You are going to see that often the last message is about the material are different. That's why they warp differently. For me, it's not an answer. I mean, if they are, yes, they are different, but why one is warping more than the other? That's the question. So anyway, that's the first post. No particular information. Except that I think we need to educate more people on what is annealing. And then it also shows, what kind of education we can do. Because at Polymaker, why we spend so much time on, this material science education is because it helps a little bit finding out great materials that you have, the good material for your application, and also help having better printing quality. I mean, it help a lot on that. So it's interesting to see what point we should focus our material or our market education. So that's for the first post. Again, not much, but we are going. I think this name we are going to see it again, Curtis. You're going to see. I think there is some funny stuff on that. So on the second group, what I asked was, everybody thinks warping is caused by thermal shrinkage expansion. Then why would PC warps more than PLA? And why would cooling makes warping worse? Okay, so that's the kind of question that we've been talking about, right? So let's see what people are talking about. So let me do by the most recent one. Okay. I think Stefan could come up with some interesting method to test those hypotheses. Yes, exactly, Nathan. That's I think the way CNC Kitchen could really help is that he's really good at finding out stuff. So if you ask him the right question, then he will design great testing method for that. Someone's on armchair material scientist there in that thread. What? Someone's an armchair material scientist. Sorry, I didn't understand the things. Yeah. Started printing with some of the Polymaker CF PLA this week. I hope it's going well. Definitely need to get a larger diameter nozzle. Had 2 print fail with my 0.4. Maybe you're not printing hot enough. Most persons are only interested to how to solve the problem without understanding why they have the problem. Francis, this I agree. What I don't understand is why people come. I'm asking a specific question, and everyone come and explain to me how to solve warping. That was not the question at all. You get what I mean? Like this, I understand. Like if I come to a group and then I say, "Hey guys, my part is warping. What can I do?" Then okay, I can have a lot of answers that say, use an enclosure, increase your printing bed, printing temperature, whatever things, depending on what they think warping come from, where warping come from. But here I'm asking a specific question, and they just go in automatic mode, and they just go and say, "Yeah, I don't care about the question. He's talking about warping, so let me just copy paste my warping solving," which it's great because that means they help a lot of people if they are very active. Because I posted all of this literally this night, so all of these answers are from a few hours ago. So they are very active, which is great. Which is a little bit less great is that most of them don't spend time, understanding what they are saying, and that's the thing I want to change. That's why I want to print bust more and more group, because I want to force people to think before they say something. Think about what they say, or use a better language when they explain something, because sometimes they use a language that says, that's how it is, that's 100% sure, you have to do this is how it is. You are going to see some people, they are going like they're talking about crystallization like this is how it is, but it's completely, in my opinion, is completely wrong. And they are saying crystallization and polymer crystallization, like going from a rubber state to a glassy state, is called crystallization in polymers. But that's wrong. And I don't want people saying wrong things. So if they are saying things that they think it's like this, that's their theory, etc., that's fine. But if they say things like, that's how it is, that's how I answer the question, and then everyone is reading that, and the problem is you have hundreds of thousand people on those groups that are reading this, and that's what I don't like. So that's why I like to print bust on these groups. So it's frustrating when people don't even seem to read the question before answering. Yeah. I guess if we stay positive, it might be because, people are often asking the same question. So they kind of just see, like, you see, if they scroll and they see this, sometimes they don't even read this. They just start writing about, warping stuff. So I mean, it's okay. It's not a big deal. But sometimes I engage the discussion, and then, they go deeper and deeper in what they are saying. So anyway, let's just go. Let's just read. Lachi Torres, because you print PC. What was the question again? Okay, why would PC warps more than the PLA, right? Because you print PC at higher temperature. It therefore has to cool more to get to room temperature. As each layer cools down to room temperature, more and more shrinkage force is applied. Okay, so looks like I didn't have time to answer that one. But of course, my answer would be, if you print PLA at the same temperature as PC, it's not going to warp. So why? So that's what I'm going to answer. But let's see, there is some discussion already. To answer your second question, part cooling will exacerbate, I guess that's the same as French, make a problem, bad situation, make things worse. Okay. So to answer your question, part cooling will make things worse. The shrinkage, as you are forcing the part to cool even faster, making each layer shrink at a faster rate than if you have no fan at all. Again, this for me doesn't make sense. It doesn't explain. The part is not going to shrink more if you cool it faster. The shrinkage is about a temperature differential. So if you go from, I don't know, 200 degree to 20 degree, okay, so it will shrink a certain amount. Whether you cool it fast or whether you cool it slowly, then it will still go from 200 degree to 20 degree. So it doesn't, it's not because you're cooling faster that is going to shrink more. You get what I mean? So that would be my my answer to that. You see, to answer the second question, part cooling will make the shrinkage worse. No, it doesn't make the shrinkage worse. It's the same. It's temperature dependent. I think we talked about this already. As you are forcing the part to cool even faster, making each layer shrink at a faster rate. Blah, blah, blah. Do you think the same rules apply for semi-crystalline material or for TPU? Both can also be printed at high temperature but don't warp. It definitely depends on the elasticity of the material and how much tension the material can take before plastic deformation takes effect. Typically, your thermoplastics such as TPE and TPU are very elastic and as a result don't have such high warp forces. Semi-crystallized such as PP and PE, PETG in our use case, are nowhere near as elastic as your thermoplastic, and as such still face supreme warp force. PP especially sucks. I print it pretty much weekly and need a heated chamber to have not warp at all. Yeah, again, it doesn't explain anything here. So this person is talking about the warping will depend on the elasticity of the material. So the more elastic the material is, and the less it will warp. Right? It definitely depends on the elasticity of the material, how much tension the material can take before plastic deformation can take effect. And then she's talking about that's the reason why PP warp a lot. But take PLA. PLA is not elastic at all. I mean, it might be the least elastic material in her example, but it's not warping at all. So she or he, I don't know what's the name, but this person needs to put all her explanation together and then try to make sense of it. Because this is another thing I notice when I'm print busting on different group. I noticed that people answered question very independently. Like they answer that question with that answer. They answer that question with that answer. And then that question with that answer. But if you put all the answer together, then they are not even the same answer. They don't make sense together. That's another thing I noticed. And this is the perfect example. This person is answering something about warping and shrinkage and the fact related to cooling. And then after that, she's talking about the elasticity of the material. But if you put, PC, for example, PC is also not an elastic material. So there is, you get what I mean? Like I noticed that a lot of people answered question independently, but they don't make a logic out of it. And that's the hard part of warping. Is like you can maybe answer part of the question with an answer, but if you try to take the other part of the question and then you try to answer it, and then you put this answer together, then that's the hard part. Sometimes they don't match. What you need to find is an answer, a logical hypothesis that would answer everything. And that's why I'm more towards the elastic shrinkage, because I like the fact that one theory answered many different questions with the same theory. And I start to have a pretty good hypothesis on the thermal shrinkage theory. So like before, I mean, do you remember when we started, it was elastic shrinkage, and then the thermal shrinkage theory was nothing. But now I've print bust so much that I start to have a pretty good, I started to put together a kind of hypothesis for thermal shrinkage that not as close as the elastic shrinkage, but much closer than what I had before. And that's thanks to people trying to answer. And I thank again all of these people that are trying to answer the questions, because we can take all of this and try to make sense of it. So that was the first one. By the way, Mike Tyson is our 3D printing expert on our Discord. I think he's the only expert. That's this one, Polymaker expert, Matt 3D PS. That's Mike Tyson, this one. So if you have some question, or if you want to challenge someone, then I think Matt Tyson is a great person. If you want to practice your print busting skill, then go and talk with Matt Tyson. Okay, let me catch up a little bit. Okay, FDAF patch. Because in the words of Neuro 3D, some people only want to print plastic boat. Not all people like to know all the details. Not everyone like being like an engineer. Yeah, and that's fine. Like I said, if they don't want to understand or take time, then then they should not even be in this conversation, right? They see the question, and then that's not something they care about, and then they just pass. But the people that stop and answer, it means either they want to help, which I appreciate, or either they also want to understand, so they kind of follow the discussion, but they want something, that's why they only want to solve the problem, not getting into the details. Yes, and that also I noticed that, like when I browse through the different troubleshoot, you have a lot of people that answer, and then I go into this answer, and then I ask, like someone has an issue, and then they answer something, and then I ask why. And then usually the explanation is really, sometimes it really doesn't make sense, like not at all. And I think is because they have answered like really quickly, and then I ask something that they were not expecting, and then they kind of start to think about it. So even if the answer doesn't make sense, my goal is that at least they started thinking about what they just said. I have warping, and then because you are printing with ABS, so don't use the cooling fan. And then why they shouldn't use the cooling fan. And you're going to see that actually one of the posts, it's exactly this. The guy is saying, why are you asking all of this question? You don't even follow the recommended setting from the manufacturers. Because I was saying, yeah, I'm printing ABS and it's warping and I'm using a cooling fan. And then obviously everyone takes me as crazy because I use cooling fan with ABS, but nobody knows why I should not use cooling fan. And they basically say you should not use because the manufacturers say you should not use. But anyway, that's later in the post. You're going to see the discussion. It's also very, very interesting. I guess because there are so many people asking how to fix a problem, and those large group, they just thought you are also one of them. Yeah, Nathan, I think it's the same. They didn't really read my question, but which is fine. Again, I appreciate people coming and then giving me their solution, and then I ask why, and then that's how we kickstart the discussion. I don't agree on that. Sudden change of temperature will cause warping. Sudden change, yeah. So Francis Bellin, that's fine if you disagree, but we have to explain that. For example, if do I have how about this? If I have this, okay, let's say it's just a cube, or not a cube. How to say in English? The square in 3D is a cube. The rectangle is 3D in what? It's called pavé in French. Francis, you need to help me there. How do you say pavé in English? But anyway, this shape, right? And then if this shape is at 200 degrees C, okay, and then this shape cools down, so you say sudden change of temperature will cause warping. So this shape will suddenly get to 20 degrees. Is that going to warp? And if it warps, then how? Is that going to warp this way, this way, this way, this way? Why this? So let me read properly. Sudden change of temperature will cause warping. Yeah. So why this part going from 200 degrees to 20 degrees will make it warp? So that's the question. Maybe sudden change of temperature will cause warping. Maybe, but why? Why? And then, oh, 3DQ. Thank you for joining the stream. I'm not talking only about 3D printing. Yeah, which is fine. As long as we explain the why. Mark, I really like the idea of the Chrysler test mentioned in the article you shared on Discord. Has anyone tried it to see if it releases enough orientation or stress of the part to be measurable? You mean the paper I shared about the guys that put a 3D printer in the X-ray? That's the one. Yeah, I actually looked for that because I was super happy to find that one, but they are looking into crystallization, which is another part of warping, which I think is the part that is very clear that it's that crystallization called warping, but nobody knows. Like nylon warping, that's another thing. If you want, you can go and print bust around. Go on different group and ask people, hey guys, I have my I'm printing with nylon and I have some warping issue. Do you guys know where it comes from or something like this? Then you are going to have a bunch of people that will ask you, increase your bed temperature, printing an enclosure, blah, blah, blah. And then ask them why. And then you're going to start, because we know it's crystallization. And for that one, we have tested it. I mean, we literally designed a filament that reduced the crystallization rate, and then you don't have warping. That's basically our warp-free technology, right? So it's 99% sure where the warping come from in nylon, because we literally changed the molecular structure of the compound of the nylon to make it not warp. So I guess it's hard to say that it doesn't come from crystallization. So, but still, you will have some people that have that thermal thing into their explanation. But yeah, to answer Mark, I haven't found anyone that do the same, but for stress relaxation. I only found that article that I shared for crystallization, which is also interesting, right? Because for PP, why this guy has issue with PP? I don't think, and I'm pretty sure it's not because PP is less elastic than TPU, for example. I think it's because PP crystallize. That's different. And PETG is because, and PE and PETG are very different. PETG, the fact that they use a different dial means it's very hard for PETG to crystallize. Actually, it doesn't crystallize. So it's not about crystallization. For me, it's about the elastic shrinkage, because the TG of PETG is higher. I don't think it has to do with elasticity, or at least I cannot make sense of it. Come out on PLA. Thank you for joining. Yeah, I'm streaming. I missed the last stream. I'm really sorry for that. I missed the Q&A on Tuesday, and I woke up too late. I was on kid duty that day, and I woke up after the stream, so I'm sorry for that. But I'm glad to coming back on YouTube. It feels good to be streaming again, talking about 3D printing. Do you run the Instagram account? Not much these days. I move it to to Oriana, someone from my team. I'm going to stick with my big gnome theory. Polygon is a prince. Polygon, can you use cooling fan with ABS? I'm getting 73 chamber temperature on the Voron, and I can run 100% cooling fan. It actually works great. Yeah, I guess, like, or at least in the elastic shrinkage theory, the goal is that you can maintain the material above TG or close to TG long enough so that it can release the stress. So whether you use a cooling fan or not will mean that you allow less time for it to release the stress. So if you use 100% cooling fan with 73-degree chamber temperature, most likely it should warp more than if you don't use the cooling fan, depending on the ABS you are using. Because if you are using ABS Plus, for example, from Eason, then their TG is around 75 degree. So it's like, I don't know if we call it a fake ABS or a modified ABS, but the fact that the TG is lower will make it warp less. Rectangular prism. Oh yeah. I was thinking why people are talking about prism. Okay, so that's how you call prism? Really? I thought prism is something totally different in French. But thank you for the translation. Most people on forums get mad when you ask them why when they tell you something. Most people on forum get mad. Okay, so print busting on groups is forbidden. I control warping at my house with no ceiling, fan room temperature. I don't have warping problem. Yeah. Stephen Poole. Again, I think we all, or at least people following the stream, I think you all know how to solve warping. I'm 100% sure. However, I'm not sure, or at least on my side, I still don't know exactly why all of the stuff we are doing are solving warping. Okay, let's continue. So Keegan Davis, I had that issue with ABS. Turned out my bed temperature was way too high, blah, blah, blah. Okay. Polycarbonate cools down a lot faster than other material. I work at a vacuum forming company, and we have issues forming things because it's so different to ABS. Okay, so that's an interesting thing, is the cooling rate of material. So what he's saying is polycarbonate warps more than PLA because it cools down faster. So I mean, it's interesting that it's a factor that, it's a different factor, like different material cools down at different rate. Okay, great. But what's the relationship between this and warping? And that's the thing I'm always frustrating. Like when they come to answer that, everybody thinks warping. Why would PC warps more than PLA? And then polycarbonate cools down a lot faster than other material. It's like, I don't know, like why let me find an example on how it is in my mind. In my mind is like, I'm saying I have a bottle of water, I put it in the fridge, and I ask people why my bottle of water cooled down in the fridge, and then the guy answer me, it's because you plug the fridge. It's because you have electricity in the fridge. It doesn't answer at all. Or like I don't know why when I turn on the switch, then the light comes out, and then the answer is, oh, it's because you are in the dark room. You get what I mean? Like, okay, maybe there is some kind of relationship, but you have to explain. You cannot let me there and don't say anything, because otherwise it's the same as, hey, why PC warps more than PLA, and then I'm going to answer, oh, but that's because they're different. Okay, thank you, but you get what I mean? So that's, for me, when I see this, is the same as telling me because they're different. So that doesn't help me much. Okay, Matt Tyson. Now I think we are going to get into some interesting answers. I think there's a few unanswered questions with the CTE theory. The theory that makes sense to me is, as filament passes through the nozzle, the polymer is stretched, which creates. Oh, okay. So, yeah, okay. So he's talking about the elastic shrinkage theory. So he's cheating. He's changing the theory. Go below TG. Yeah, Matt Tyson. If you're watching the stream, you're cheating. The idea is to stay in the same theory and then try to explain, not changing theory. So why does nylon warp since it has a very low glass resistance temperature? Both nylon and PLA are semi-crystalline. Yeah. So you explain everything. So that's why I don't print bust with Matt Tyson, is because we think the same. I mean, we've been working together for like 6 or 7 years, so we have been developing similar experience with 3D printing. So there's no point to print bust with Matt Tyson, because we kind of answer the question in the same way. But the knowledge we have built together is because we kept challenging each other on these topics, and that's how we came up with the knowledge we have at the moment. So yeah, sorry. Finally, this answer won't be very useful for you guys, because that's a different theory. Okay, next one. I have an interesting link about shrinkage and warping explanation. Can I post link here? Francis, I don't think you can post the link, if I remember well. But you can put it on Discord and then ping me, and then I will open it. I will open it for you here, and then I will post it on YouTube. It's about injection molding plastic, but it can apply to 3D printing also. Yeah, injection molding is a great way to understand a little bit more about polymer behavior during processing. Higher thermal conductivity would make one filament cool faster. Yes, non-fab. Let's just say most of users don't know the answer you're looking for. That's fine, one Raz. But what I believe is, if we keep looking, I think we will try to be. We will build an answer. I don't want to think, okay, wherever I go on the internet, then I'm not gonna find my answer, so there is no answer. No, I want to keep asking, and then you have more and more answer, more and more people thinking about it, and then slowly we're gonna get closer and closer to the answer. Because if we give up now by saying, okay, nobody knows, then we'll never know, basically. So that's why, the fact that someone are highlighting, the different cooling rate, make me think a little bit more, because I haven't really thought about what if two different polymer has different thermal conductivity. I haven't thought about this being one of the reasons that it warps more than the other. I believe all polymers has basically the same thermal conductivity, but that's one thing that we can look for. And that's through searching, through questioning, that we are going to build an answer. So that's the reason why. I'm not expecting someone from the group that suddenly, write me a paragraph that will solve all the problem. I'm definitely not expecting that. But I'm expecting people trying to answer, and then I'm going to challenge them. They are going to come up with better answer. And then through that process, I believe we can come up with something good. I mean, we've been working on warping for 5 or 6 weeks now, and to be honest, I built a better knowledge on polymer behaviors in 3D printing, and I hope you guys too. And that's the idea behind print busting in different groups. Did you try the one rise? Okay. Thermal conductivity PC 0.19 watt meter Kelvin and PLA 0.13. Yeah, maybe we can try to plot a little bit more. Like, for example, we know, for example, if you're non-FAM, if you have PC, PLA, PTG, ABS, then that's 4. And then we can try to see, because we know PLA warps less than PTG, PTG warps less than ABS, ABS slightly warp less than PC. So if we plot the thermal conductivities, and then we can see that the higher the thermal conductivity and the more we know it's warping, then it starts to be interesting. And then we can start to look at it. But if you see the thermal conductivity on ABS is lower than PLA and PC is higher than PLA and PTG is the lowest one or something like this, then there is no particular correlation between thermal conductivity and what we experience as warping for this polymer. Then maybe it's not an interesting topic. I just did in warping thread in Discord. Okay. So PC will cool faster for the same delta temperature. Yes, non-fun. Okay, let's look a little bit at this. Shrinkage and warping of plastic material. In injection molding process, when the high temperature plastic is injected into the mold part start cooling due to thermal expansion and construction of the material, the plastic continue to have material-specific volume reduction during the cooling process. The reduction in volume and shrinkage of plastic, blah, blah. The shrinkage phenomenon will continue until finished product cools down to room temperature, and then the volume shrinkage change does not reach an equilibrium state. However, some materials, even under room temperature, because of moisture absorption, blah, blah, blah. The so-called product warping referred to the deformation of the surface appearance of the molded product, which makes the appearance of the product enable blah, 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 blah. In other words, the main cause of deformation or warping of the product is the uneven shrinkage of the product at the local location. However, there are many reasons for uneven shrinkage and deformation of the product. For example, the internal stress, flow stress, and shrinkage stress. Yeah, so that's basically like 3D printing, like we're talking. Is that coming from elastic shrinkage or is that coming for thermal shrinkage? So I think he's calling elastic shrinkage flow stress and thermal shrinkage shrinkage stress of the product generated during the molding process, because the product has more severe molecular chain orientation effect at certain position, or the orientation is reinforcing fibers in either the wall temperature distribution of the wall. Yeah, so that's the same. It doesn't, it doesn't, what it explains is that, it can come from molecular orientation, which is the elastic shrinkage theory, and it also comes from the thermal shrinkage, which is the shrinkage rate. Right? And what they add on top is that the shrinkage rate can depend on the molecular orientation, which is normal, right? Thickness, direction, blah, 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 and will affect each other. So to make the product has more uniform shrinkage after molding, degree of deformation and warpage of the product can be accepted or can be adjusted, blah, blah, blah. Yes. Effect of material type. Non-crystalline plastic has a lower shrinkage value. So non-crystalline plastic has better uniformity than crystalline plastic. For injection product, the thickness distribution of the product or a design gate location, blah, blah. High molecular orientation effect in flow direction will produce due to the high shear effect in the flow field. Well, the good thing is that they explain the elastic deformation pretty well, right? That's exactly the cause of warping. In my opinion, the main cause of warping comes from this. The high molecular orientation effect in the flow direction will be produced due to the high shear effect of the flow field. Okay, so that's the velocity curve that we talked about in the nozzle. That's for me the main reason why the polymer is stressed when you're printing. This molecular orientation effect will also cause the overall shrinkage of the product to have different direction and asymmetry. Yeah, and it's the same in 3D printing. Depending on the nozzle path, then the stress will be oriented in different direction, and that's why on Twitter you have that's why on Twitter what's Dop- Doppler Doppler effect? No, effect. There is what's the name? Doppler effect, I think. He made a test that was interesting. What's the name again? Well, you know what? Warping, shrinkage, thermal. Maybe that's the right. Drop effect. Okay, so drop effect made a test. Okay, this test, and then basically what he was saying is if it will warp different way depending on if it's elastic shrinkage or if it's thermal shrinkage. And it happened that it warped in a way that explained elastic shrinkage and drop effect. That's how he confirmed, in his opinion, that elastic shrinkage is the main theory, the one I support, because of this, and that's because of the orientation. So what he's saying is the thermal shrinkage is not really molecular orientation dependent. It's like it's dependent on the temperature, but the elastic shrinkage is depending on how the polymers are oriented. So for example, this cube actually warp this way, right? Like the back here warped up, and the bottom here. And what he was saying is, if it warped this way, then it means it's because of elastic shrinkage. If it warped evenly all the corners, then it means it's thermal shrinkage. And it happened that it only warped in one way. I don't know if he has. Yeah, so that was his thing. So if it's thermal contraction, it would warp this way. If it's print orientation, then it would warp this way. And then it happened that it only warped this way. So that's how he confirmed that the theory that we had was correct. But again, depending on what you think his test is, because maybe you can criticize his test. There is some discussion around the test, and he did another test, which was a kind of it was a circle, and let me check shrinkage. So what was the name? Drop effect, right? Drop effect. He made another. Yeah, he kind of explained a little bit why he designed this test this way, blah, blah, blah. So I don't remember why I talked about this, but yeah, I got lost a little bit. So we were what were we doing? We were doing this, right? Oh yeah, flow direction, blah blah blah. This molecular effect will cause the overall shrinkage, blah blah blah. Okay, the thickness of the probe, blah blah, blah. Okay, crystalline plastic produce crystallization cooling process. Yeah, for the crystallization theory, we all agree with that. There's no particular problem. Effect on additive reinforcement, shrinkage and warpage. Okay, so granular flavor, blah. Yeah, actually, you know what? I read this very quickly in diagonal, but you know what they are saying here? It's very, very interesting for how you compound material for 3D printing. I'm not going to read it now, but let me share that in the chat. So if you are interested in if one day you want to formulate material for 3D printing, then have a look at what they say here. It's interesting. Yeah, because it is not easy to make material for 3D printing. I know maybe some of you think that, and actually there is a lot of manufacturer that just throw the pallets on the extruder and just make filaments, but we are not doing that. We are compounding, we are formulating the filament for 3D printing. We don't just take like pallet from injection molding and then throw it in our extruder and then making filament, right? So it's a hard process. It's a hard process. How much would draft of cool air affect warping? Would draft of cool air? I don't know what it means. For PTG, 0.16, 0.2, ABS 0.14, 0.21. So maybe it has an effect, but the numbers don't confirm anything. Those two materials have similar conductivity. Yeah, but that's an interesting factors that I haven't thought about before. We can investigate that one, the thermal conductivity of material, if it has something to do with thermal conductivity. I tried something today. Logitech webcam, downloaded Logitech and run it a quick cam, blah, blah, blah. Okay. Experiment with various color and material. Okay, so what else do we have? Steve Lewis, cooling cools the outer edge and skin first. Cooling causes shrinkage. When the inside stays warm and large and the skin shrink, it will reflect towards the cooling. Use as little cooling as possible. Allow the whole part to cool once finished. Okay, so maybe one thing here. In 3D printing, because every time someone answers about thermal shrinkage, they think that, when you print your layer, the whole layer stay warm, and then suddenly it start to cool, and then that's what creating warping. Or they think that the whole top, like there is 1 centimeters of thickness at the top that stay warm, and then is somehow cooling after. But if you check thermal, how do you call that, like thermal video, then you will see that the whole part is basically at the same temperature, almost at the same temperature already. You only have a few centimeters outside of the nozzle that is hot. Actually, if you use cooling, then the whole part is at the same temperature. If you don't use a heated bed, if you use cooling, if you don't use a heated chamber or something, then the whole part is at exactly the same temperature. You only have a tiny bit right after the extruder that is at a different temperature. Because every time I see the same thing is, you have a layer, you put that layer, is very hot, and then it cool down, and then you put another hot layer, and then it cool down, and then another top layer, and then it cool down. But it doesn't work this way. 3D printing, we all say 3D printing is layer based, but it's just layer based, right? It's not building layer by layer. It's not putting a layer instantaneously. It's like a path. So one thing I want to highlight, because I've seen this a lot, and even people are putting schematic, and then they always put a whole blue layer, and then an orange layer, and then a red layer, but that doesn't work this way. It's not true. That's exactly. By the way, I'm still working on inviting Helio Additive on the stream, and I want to get them to share videos and data that they have, because you hear me saying all of this because I've seen it. I've seen the the research they are doing, so it's easy for me to say it. But I want them to show to you guys, like what they have been finding out, and what's the video, how it looks like, how is the temperature in 3D printing, and then that would highlight why for me it makes so much no sense to say this way. Darcy Barnes, that's exactly what it is, hence why things like fan shrouds, heated enclosure make massive differences. That's exactly what it is. Okay. So why would PC warps more than PLA? Because that's exactly what it is. Hence why, well, okay, yeah, I don't understand, but it has 2 likes. Let me give one more. I used a bed adhesion spray, work a lot better, blah, blah, blah. Okay, so that's for 3D printing Oz. Was in the pool. Builder's mark. Well, actually, a lot of you are on a holiday, right? Like summer holiday, right? Okay, next one. Because I want to get to the one that has something funny in it. Okay, so on this one, hi Mark. Oh, we have a new Mark. Oh, we have a new Mark. Builders Mark, Mark UFU, Mark Andraka is still there, I think. If Mark Andraka, you write something now, then we have the 4 marks, one after the other in the chat. Builders Mark, Mark UFU, Mark Benton, and Mark Andraka. So we have the Mark team for the giveaway. Mark Benton, I don't know if you were there in... oh, there you go, Mark Andraka. The Mark team is complete. Yeah, Mark Benton, I don't know if you were there in the other, but we had a time where the Mark was winning everything. So for our giveaway. Or is that someone that changed their name? It's actually Kevin Benton, the change to Mark. Anyway, so the next one is for 3D printing. So here we have 100,000 members. 100,000. Okay, so what did I ask? If warping was caused by thermal expansion shrinkage, then why cooling makes warping worse? Okay. So again, my question is so broad, but the idea is just to get people triggered and then start talking. I want to extract information from people. Radical change in temperature I use to turn my heat bed off after 3 or 4 layer. Don't keep it on to keep the ambient temperature stable. Okay, it doesn't help. It depends on the material. Some material needs to cool slow. Rapid cooling will warp it. Some needs rapid cooling. Okay, so interesting. Do you know why some material would warp I guess my meaning was when cooling them rapidly and not other? I have done some research, but I cannot find any good explanation on why 3D printing parts warp, which is true, right? I don't really know. I think it's molecular or has something to do with the polymer strings or something like that. I don't really know. I'm also more referring to warping in general, not necessarily warping of the bed. My PLA will curl upward on overhang, causing the nozzle to crash, blah, blah. But other material needs to cool down and need heated enclosure with fan off to avoid warping. So I end up the discussion here because, well, he doesn't know, so I don't need to push it more. My interest is to push the people that, you know, they think they have a logic. So I want to push the logic until the end. So for him, the logic stop here. It basically, depending on the material, some like cooling, some doesn't, and the logic end here. So that's fine. So that's my goal. I try to push people to the end of their logic. It's not that cooling is making it worse. Uneven cooling, it is making it worse. The thinner pieces cool faster than the corners that have a higher density of plastic and takes longer to cool. So the middle stretch of your outside perimeters is cooling and pulling tension from the corners towards the middle of each wall. The vertical edge of the corner takes longer to cool. When it does, any molecular slack in the horizontal direction has already been removed by the cooling of the outside perimeters, and so the only direction for the corner's edge to shrink is vertically, which pull the corners up and off the build plate. Yeah, to be honest, because I read this already, I didn't understand. So I just answered the first thing because I tried to understand the second part, but unfortunately I didn't. So what I said is, if uneven cooling is making it worse, then having a very powerful fan would be useful. I would cool down everything to room temperature quickly. If I don't have the fan, then everything would cool down very unevenly, making my part warp more. So my idea is, you know, like I said, if you cool down the part, then and you don't use a heated bed, then the whole part would be basically at the same temperature. But if you don't cool down, then you have a long string of material that cool down very slowly and very unevenly compared to the rest of the print. So I'm saying, if you use a cooling fan, then you make it better. It warp less. The best way to avoid, and then he completely go off track. Like the best way of avoiding warping would be a heated chamber. So the first thing, we don't care. A powerful fan would be good if you can guarantee it's going to cool everything evenly. If it's blasting from one direction, the far side of your printed object is not going to be cooled the same as the side that is in the direct stream of air. So I told him I have a 360 fan duct and a powerful fan. And I told him, since I use this, even if I use a 360 fan and it's cooling down everything from all direction, then it's making my ABS much worse. And then, do you remember Colin? I think that's the one that was before. So basically, there is your problem. Why are you using a fan with ABS? You are asking a bunch of hard-hitting questions about concept that are complicated, but you forgot to find out what the recommended setting for ABS are. Now it's 100% your fault. It's warping. Typical Facebook problem. Why do you bother wasting your time? Wasting my time. So again, yeah, I don't know what to say, but that's oftentimes you will have this kind of thing where I'm stupid because I'm not following the recommendation, blah, blah, blah. So I'm stupid because I'm trying to understand things, right? And apparently that's a typical Facebook problem, that people are trying to understand. And, these stupid people that are trying to understand, just follow what people tell you and then don't look for more. I very well know that the recommended setting for ABS is the fan off. Do you know why the fan would make it warp? If yes, I'm looking forward to your answer, because this is what I'm looking for. But unfortunately, I didn't have an answer from that guy. Next. Well, there's so many Mark talking now. For your information, Facebook scam warning company. Okay. That's going to leave a mark. I like how Nick's mission is to trigger people for science, of course. Yeah, art match animation. I think from 90% of the people, from 90% of people point of view, I'm a very bad guy. I'm the guy that is going to mess up everything. I understand, and that's the first thing I explain in PRINTBUSTERS. PRINTBUSTERS is something very different, and people don't like different. They don't like different. They don't like people arriving on Facebook and asking questions that nobody has asked. People don't like that. You can see here. I'm basically wasting people's time because I'm asking questions. So, but the thing is, I was alone before, but now I feel more comfortable because I have PRINTBUSTERS. I'm more comfortable because now there is a community that is actually looking for that. So I'm now fighting for something, not only for me, not only for my curiosity, not only for my seek of 3D printing knowledge. I'm now fighting for a community, for a bunch of people that are like me, that want to understand more, that don't want to just listen to increase your bed temperature and then that's it. Don't bother me anymore. I'm fighting for something. So I like it more now to print bust on different different forums. Does anyone else love tree support? I personally don't like it. I explain why in a different stream. We should have a separate giveaway just for the marks, just to give everyone else a fair chance. Yes, Mark and Draka, I think we talked about this last time already, right? We need a mark giveaway. Where was I? Blah, blah, blah. 90-degree overhang are fun. I need black filament, but it will have to wait a bit. Yeah, don't worry, Mark Benton. You are a mark, so just wait for the giveaway. Hey, make a muse right. How are you doing? Were you streaming today? If yes, how was the stream? Thinking out of the box need mind flexibility, and not everyone is flexible. Yeah, a non-fam, 100% agree. If you are part of PRINTBUSTERS, you need to be open-minded. Otherwise, it's not going to work. I mean, for example, we had a long discussion with Kenado, right? And then at the end of discussion, I don't think he gave up, but he didn't want to talk anymore. Like I think I pushed it a little bit more, too much, I think, Kenado on his experience, because I mean he was one of the guys that has a very good way of thinking for the thermal shrinkage, but unfortunately the discussion has ended, and then it went from a different discussion. So it's not easy. I mean, PRINTBUSTERS is not easy. Different is good, and the search for information is noble. The only dumb question is the one not asked. Yeah, there's no dumb question. There might be easy question to answer, there might be harder to answer, but there's no dumb question. How do you even define a dumb question? I'll just enter the contest. No, sir, not today. Oh, you didn't stream today? Okay, got it. Yeah, you can enter the giveaway, Make Your Meals Right. I mean, it doesn't really matter, right? Whether you win or not, if you need filaments. Have you received the prop, the beta testing filament yet? You are the only one outside of the US that I send it to. Okay, next, Jez Clark. The thing that creates warping is the temperature difference between the plastic glass transition temperature and the ambient temperature of the air. The bigger that difference, the more it warps. So if you are blowing cold air, maybe 15 degrees in a very cold room over ABS, TG over 100 degrees, that's a lot of thermal contraction. Cooling from molten temperature down to TG, however, does not cause warping. Okay? Sorry, I need to drink. This is why, in an ideal world, the ambient temperature of your enclosed printer would be 20 to 30 degrees below the TG of whatever material you're printing. And you would use a powerful fan to blow air over the print, so you cool to just below TG and no further. Then once the print finishes, you let the ambient temperature of the enclosure gradually drop. So the whole print cools and contracts together slowly, which result in less warping, compared with some layers contracting more than other during the print because they are overcooled. Okay, this I haven't read this answer before, but I think it looks very interesting. So let's dissect that answer. The thing that creates warping is the temperature difference between the plastic glass transition temperature and the ambient air and the ambient temperature of the air. The thing that creates warping is the temperature difference between TG and the ambient air. Okay. The bigger that difference, the more it warp. Okay. But why? Why the bigger? So if you are blowing cold air, blah, blah, blah. Yeah, but why? Why if I just said why like 5 times in 5 seconds? Why again? Why if you create warping? Why the difference in temperature would create warping? Like what? So that, yeah, I actually I don't understand, because I'm picturing, let's say you have if you print PC, yeah, I mean, I don't understand. So I understand what he means is the higher the temperature difference there is, the more it warps. But why? Why if a plastic TG is 100 and then you print in a chamber that is 30, then it's going to warp more than if you print in a chamber that is 50. I mean, it looked like an interesting answer because of the vocabulary, but now that I'm thinking about it, then actually there is no answer, right? It's the same as the guy that was saying, some material cools down faster than other. Then his answer is basically this. His answer is some material has a higher TG than other. Yeah, I mean, we know that. But why? Why does the higher the TG and the more it warps? Or did I miss something? The thing that creates warping is the temperature difference between the plastic restoration temperature and the ambient temperature of the air. The bigger that difference, the more it warps. So if you're blowing cold air, maybe 50 degrees in a cold room over ABS, that's a lot of thermal contraction. Okay, so he's talking about thermal contraction. Cooling from molten temperature down to TG does not cause warping. Okay, so that's interesting. What he's saying is, whatever the printing temperature, it's not going to affect warping. Oh, okay. Now I get it. So that's actually, if you go in our warping discussion, actually this guy is interesting. We should invite this guy in our Discord, because his thinking is one of the open end in our warping discussion. Because that's exactly why I ask you guys if you could experiment printing at a different temperature. You know why? Because that's one of the big difference between his theory and the elastic shrinkage theory. In the elastic shrinkage theory, the hotter you print, the better the warping. I mean, the less warping. But in his theory, whatever the printing temperature, it's not going to affect warping, only the TG of the material. And why I disagree with that is because in my experience, when printing PC, if I print PC at a high temperature, it will warp less than if I print at a low temperature. Like if I print PC at 230 degrees, it's going to warp like crazy. If I print PC at 300 degrees, it's going to warp much less. If not at all, if my part is small enough. So that's what I'm going to answer him. Like first, I'm going to confirm. Usually what I'm going to say here, I'm going to say, thank you for answering. Do you mean that whatever the printing temperature, my warping would be the same? For example, if I print ABS at 260 or 230, then will the warping be the same? Because he's talking about cooling molten temperature TG, however, does not cause warping, right? And that's a good way to for me to put out this theory, because printing temperature does affect warping. So this theory for me is wrong because of this, or needs some adjustment. But it's interesting. I really like this. I really like this answer, because it takes into account much more than the other answers. It really thinks about different perspective. Unfortunately, from my experience, it does not work this way. But the logic is there. We don't talk about that, but he will be here next week. I'm so excited. Why the way Coca-Cola tastes weird in China and the cans are steel? Well, I don't drink soda, so I have no idea. Why? But why? Yeah, I'm a big why guy. I'm a big why guy. Hey, Everything Plus Ultra, thank you for joining the stream. I think you're also part of the beta testing for our new materials, right? If I remember well. I think we have 2 people in the chat that are part of our beta testing. Okay, next one is the more cooling, the more it shrink. This is the kind of answer I like also on Facebook. It's like, this guy believe there is dumb question. Because definitely he considered my question as dumb. The more cooling, the more it shrink. That's so logical. Why are you asking? So what I said is, I thought shrinkage was calculated with a temperature differential. The part will be at room temperature anyway, so whether you have more cooling or not doesn't matter. Exactly. So if built in an enclosure where the air temperature is much higher, the temperature difference being only enough to solidify the plastic, there will be much less shrinkage while solid, so much less strain buildup, so much less likely to warp or pull itself off the bed. I run hips in an enclosure which maintain about 55-degree air temperature and no fan cooling on the part. In fact, I will take the part fan off next time I maintain the printer to save weight. PI bed at 105 and never have any shrinkage or part separation, never. Yeah, I mean, you're not going to leave your part in your heated chamber forever, right? At some point, you're going to remove it. So it's gonna be at at room temperature anyway, like I said. Exactly. So if you build an enclosure where the air temperature is much higher, the temperature difference being only enough to solidify the plastic, there will be much less shrinkage while solid. No, it doesn't make sense. The more cooling, the more it shrinks. It doesn't explain. It doesn't explain why. You go from the printing temperature to the room temperature anyway. The enclosure is not helping in any, except if you print a part in an enclosure at 60 degree and then it stays in the enclosure forever, then yes, it will shrink less because you just leave it in the enclosure, right? But at some point, any parts that is printed will be at room temperature. So that's not an explanation. Duh. So if I build an enclosure, blah, 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 there will be much less shrinkage while solid. So much less strained buildup. So much less likely to warp or pull off. Yeah, doesn't make sense for me. By the way, if it makes sense for you, then let me know. Then I go back and then I dissect the comment a little bit more. But for me, yeah, it doesn't explain anything, and it doesn't bring anything to the table either. I don't think there is some stuff that we haven't thought about before. If I were to print ABS nylon, personally think it would print better in an enclosure with temperature control inside. Rover, it depends. For nylon, if you print with our nylon, with our warp-free technology, printing it in a heated chamber would actually make it worse. So that's why it's important to understand where warping comes from. Because if, we have a bunch of people that print with our nylon and then it's warping and then they use an enclosure and then it's warping more and then they use a hotter printed bed and then it's warping even more and then they throw away the filament. Because they don't understand. They have no idea why they should increase the bed temperature, why they should use an enclosure. They have no idea. And then they throw away the filament. Because with our nylon, it's about the crystallization rate. So if you increase the crystallization rate by giving it more energy, more temperature, like enclosure, bed temperature, then you're going to make it warp more. So that's why listening to whatever is on Facebook sometimes doesn't work, because you didn't ask why. If you go on Facebook, you say, "Hey, my nylon part is warping. Can you guys help me?" Yeah, increase your bed temperature, increase your unclose your printer, increase your heated chamber. And then, okay, thank you. Oh, it doesn't work. Oh, increase more. Doesn't make sense. Okay, next. Plastic needs to cool if extruder keeps running over hot plastic. You get curl, especially if ambient temperature is a little on the colder side. You can print a raft or use a brin to get better surface coverage and more accurate force layer. So if I cool down my layer faster, then I would have less curling and warping. Slower layers, you can print more of the item to increase layer time and set minimum layer time in Cura, blah, blah, blah. Part cooling helps only to an extent, but mainly try using a brin first, then raft second. So I'm asking why the part cooling only helps to an extent. It seems to be much more efficient to cool down the layer with a fan instead of increasing the layer time to have more time to cool. In general, the part cooling fan of your printer, the part cooling fan on your printer are not designed with best performance in mind and use smaller fans that are less effective and not aimed properly. Many upgrades are available for download that can significantly increase performance. So what he's saying is, if you have a very performant cooling fan, then it will solve your warping issue. And again, we all know that it's not true. But you see, because if at the beginning I would ask him, is it better to use a cooling fan or no cooling fan to improve my warping? Then I'm 100% sure he would have said, yeah, don't use a cooling fan. That's better. But the fact that I go through an answer to another answer, now his answer is, the more the cooling, the better the warping. You get what I mean? That's what I was saying about answering independently different question. Because now he's putting answer together and it doesn't make sense anymore. We all know that if you use cooling, then it's going to warp, right? So he didn't continue the discussion. Gross bro recommending raft. I don't like them either. Blah 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 blah. Okay. Yeah, I'm also not a big fan of raft. Okay, so that was for this one. I am, and printing 2 prints, same setting for both samples. Great. Looking forward to your feedback. Everything plus ultra. If I were to print ABS nylon person, I think. Hey zombie, still on vacation? Sorry, kid would not sleep. I know that. I agree that we need to ask questions, but you shouldn't use scientific tests to verify hypotheses. At the end of the day, we want scientific answer to the question we talk about. I agree that we need to ask questions, but you shouldn't use scientific tests to verify the hypothesis. I think we should. Wait, maybe I didn't understand the question. I agree. We need to ask questions, but you shouldn't use scientific tests to verify the hypothesis. At the end of the day, we want scientific answer to the question we talk about. Yeah. I agree, Francis. But the problem is I cannot find the answers. So yes, I also want answers to the question I'm asking. But currently I cannot find answers, and that's what that's what we're doing here. We're trying to find answers to our question. Our question is where warping come from, and now we are trying to find answers. And we have done some scientific experiments. Some help, some less, but we haven't done any particular experiment that really settle, the debate. We have one that is the nylon that we have done, which kind of settled the debate around why nylon warp, even though you still have 90% that don't think about crystallization for nylon. But at least we know that why nylon warps, or why PP warps, or why semi-crystalline warp in general. But for amorphous material, that's where the debate is still there. My point is that we can do experiment to answer this question. Francis, if you know an experiment that can answer, then please share, because that's another question. What experiment would be able to allow us to understand better warping? Death before raft. Stephen Poole, I agree. It seems that in the community there is team raft, team no raft. I'm more in the team no raft. I don't like raft. It's hard to remove. It's like I said last time, raft was invented for beds that are not flat, because you can level your bed, but if the bed is not flat, then you need a raft in order to create a flat surface. But if you have a flat bed, then you just have to level, and then that's it. I mean, raft is useless except for that. I actually just got a full filament PEI sheet, and damn, it's nice. Filament PEI sheet. Okay, are there different type of PEI sheets? Because I know PEI is good, right? I mean, that's the default one. Was the default one on the loose board, right? And I really like it. My bed is so warped, I pretty much have to use a raft. Yes, so that's the only reason why I would use a raft. If your bed is not flat. I think I printed with one raft, never again. Yeah, great. I'm happy. Most of you are in team no raft. Okay, so what did I ask here? If warping was gone, why would cooling make it? Oh, we did that already, right? Oh yeah, we did that. Okay, next. Next. I know it's a difficult question. So this was on Prusa. So I was expecting a lot from the Prusa community. So there is 32 comments. So I think there is some reading there. I know it is a difficult question, and I have done my research, but I cannot find anywhere a good explanation on why parts warp in 3D printing. So if you have some ideas, or if you know the root cause, I would love to read your comments. Thank you. Okay, let's get into that. Let's start by the beginning. Warpage is due to temperature differences across the part. Okay, doesn't help, because when you look at thermal videos, there is no temperature differences in the part. If you're printing, like I said, if you're printing with cooling fan and no heated bed, then there is basically, I mean, we can, I don't know if there are thermal image 3D printing. I think I have some footage somewhere, but yeah, for example, this one. If he's using a heated bed and he's not using cooling fan, but even though he's not using, he is using the heated bed, you can see that most of the part is the same temperature. And even if he's not using the heated bed, then all of this part would be the same temperature. And if he would use the cooling fan, then all of this would also be the same temperature. So let me check. Like this one, for example, is not using cooling fan also. I mean, it's very easy to see. There's you just type on YouTube. You just type on YouTube thermal. Well, basically this. Well, you know what? Let's go. Let's just go. There's a guy that did the difference. Was it this guy? There's a guy that did a video with and without cooling fan. I show it to you guys last time. Thermal video 3D printing. Is it this one? I think it's this one. Yeah, it's this one.
Temperature gradient is gone.
You see? So this is after. So he was basically showing without the cooling fan. This is without cooling fan, and then this is with cooling fan. So with cooling fan, and then he said without the heated bed, basically the whole part is the same temperature.
A small temperature difference.
Right. So if you are talking about temperature differences is causing the warping, then you have to explain more, because I don't see any temperature differences in the part here that would explain warping. Okay, so a guy is pointing me on how to fix warping. Doesn't really help. I'm trying to understand the root cause of warping, not much how to solve it. But thank you for sharing. All plastic shrinks during cooling. How much they shrink depends on the material itself. That's why they tend to warp differently. I found quite a good English article about it. You'll find the amount of shrinkage, etc. So I read that article. It's pretty interesting. Actually, I should put that in. I should put that in the follow the link in the Discord. Is interesting. Let me remove the reference. Let me put that here. Okay, so I put in our Discord. It's interesting. It doesn't explain warping, but it does some test on how much a part shrink. I think Zombie was asking about this. How much does a part shrink, and then how to compensate for that. So Zombie, if you're still there, then I highly recommend that article. However, inside they say while the shrinkage rate of PLA is between 2 to 2.5% and 1.7% for nylon, you will still have to take in consideration for both, blah, blah, blah. So they basically say for nylon, then you have to scale it up more, less than for PLA, blah, blah, blah. So like I said, they don't really explain about warping. But what I answer is, in the article, they say that nylon shrink less than PLA. Then why nylon warps more than PLA? Unfortunately, I didn't have an answer, but that was my follow-up question. Okay, and then we have another one that is doing bimetallic. Again, bimetallic is also an answer I've seen everywhere, but bimetallic is different. Bimetallic is a whole layer. Like bimetallic is two different metal with two different coefficient of thermal expansion. So when you heat them up, or when you when you cool them down, then they will warp in one way or the other way, because they don't have the same shrinkage rate. But that means it would be correct if the whole layer is put down at once, right? Like all the other explanation, which is not the case. So we need an explanation that explains why this is the case, like why we should refer to bimetallic. If it's like single string by single string, you know what I mean? Like it's some shortcut in the explanation that I don't like. It's fine to take shortcut, but I will always be the one that says, okay, you have taken that shortcut. Can you please take me through the long journey on why we go from here to there? My understanding is that the first layer remains warm on account of being in contact with the build plate, while upper layers may cool down upon being in a cold air, resulting in upper layers contracting to a length shorter than bottom layers, which then forces the bottom layer to curve and warp. So basically, parts are warping because we are using a heated bed. Okay? So, of course, my answer is going to be, then we can solve warping, but by not using a heated bed. I don't know the chemistry of the different materials, so I might need to say adhesion, blah, blah, blah. However, if you do unclose the printer, blah, blah, blah. Yeah, and then he say each plastic are different. Okay, so then we have someone else that is coming. It's well established that not only you need a heated bed for ABS, most people benefit from a full enclosure. This prevent draft, blah, blah, blah. So I say, yes, I understand that it is well established, but unfortunately, nobody knows why. Okay, so we all know how to solve warping, but nobody knows why this solve warping. But that discussion is very interesting with Steve, because a lot of discussion end up like the discussion with Steve. A thick PI sheet make it more flat and has good surface to bond to. Okay. I have a question for you. Is warping happens only during print, or can it happen after the print is over? I think it can happen after. It happened during and after. I mean, you can think about it, Francis. If, let's say, so during the printing, well, actually, that was your question basically. But yeah, it can happen after. Even you just finish the print, then it will continue to warp. First, I think during printing, if after print it cool down too quickly, also think it may warp. Yeah, I mean, if you anneal it, also it may warp. If you just leave it like this, it will warp. Does the X1 use a heated bed for ABS? I'm not sure, but I would guess so. What, like we reviewed last time, I don't like the X1 saying that they are good for ABS, because they are not. They are good for printing small part of ABS, but they don't have a heated chamber. If you don't have a heated chamber, you cannot say that your printer can print, ABS. Or you need to say, our printer can print small ABS parts. That's fine. Because on their Kickstarter is basically our printer can print. I even asked the guy from Bamboo Labs, and then he said, yeah, our printer can print an ABS because it's unclosed. No, I'm pretty sure if you print a cube, in an ABS cube in the X1, it would warp like crazy. I'm 100% sure. And we still haven't answered the question. Do you remember the X1 Carbon and the X1? In their Kickstarter, they say that the X1 Carbon can print PC and ABS, can print PC and nylon better than the X1. Why? We still didn't answer that. Nobody has answered that. Why the X1 Carbon would print PC and ABS better than the X1? Because they both have no heated chamber, which help preventing warping. Okay. So I say nobody understand. Yeah, nobody knows why. And then they say they do. So we do know why. Just not a molecular level like you're asking for, because it isn't really beneficial. Most people don't have advanced chemistry degree to be able to understand it either. You would probably need to talk to someone who designs and manufactures the raw materials used to make the filament, or a college professor to get the answer you're looking for. Maybe someone will prove me wrong, but it just seems like this is a question above most user levels, simply for curiosity's sake and not function. So my answer is this, because they do not. If you cannot know an answer, but yeah, this is my answer. That's the thing. I don't think people do know, because the answer have no scientific basis. Most people answer what other people answer, or what they have experienced. So basically, when you ask people where warping come from, they are going to answer because material shrinks when it cools down. Does that mean they know? No. Because Steve's answer is, yeah, we know. It's just that we don't know at the molecular level. But no, nobody knows. If someone knows, then he can explain. It doesn't have to go on a molecular level, but at least he can explain why a material, why the fact that the material shrink makes warp. So when he say we do know, what he means is we do know it comes from the material shrinking when you cool down. But actually nobody knows. And that's the thing that is a little bit frustrating. Yes, we know that materials cools down when, yes, we know that material shrinks when it cools down. But how does that it related to 3D printing warping? What's the relationship? That's the thing that nobody knows. And that's the thing that he thinks that we don't care. Most people answer what other people answer, or what they have experienced, but very few people try to understand why. I do agree that it is a difficult question. That's the beginning of my post, because I start the post by saying it is a difficult question. So I warn people that it's not an easy question. I do appreciate you taking the time to answer. I hope more people will try to investigate the warping phenomenon further. People know how to solve warping, usually. However, they do not know where warping comes from, usually. So usually you know how to solve warping, but you don't know where it comes from. The answer is no, not the chemical property reason. On our level, we call the root cause something like material shrink when cooked unevenly abruptly. Okay, so that's exactly what I said. People think they know where warping comes from because they say material shrinks when cooked unevenly and or abruptly. And how do they know that? Because they go on Google, they type 3D printing warping, and then the first article says it's because it shrink. So because it shrink, nobody look for a reason. We know the properties of the material, so that becomes our root cause. Even as an engineer in the polyethylene, polypropylene foam industry, we address issues similarly, such as how some material had lower surface energy than other, which make it difficult, blah, 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 blah. We approach. I would honestly be willing to bet a lot of filament manufacturers, each with their own unique formulation, would approach a question like this in the same way, which is going to find an answer specific enough for you, even more difficult. Just something to consider as you search for that type of information. But again, I disagree. I mean, I work for a filament manufacturer. I know the formula. I know everything about the material. I still don't understand why it is warping. So it's not because I'm going to talk with a filament manufacturer that suddenly I'm going to get the perfect answer. It's really nobody has done research on why 3D printing parts are warping. It's just that in injection molding, you have uneven cooling, because injection molding, you're basically injecting a mass of molten polymers into a cool, maybe preheated mold, and then it will cool down, and then it cool down unevenly because it's so big. But 3D printing is so different. And then we just say, oh, this is how it's happening in injection molding. It must be happen this way in 3D printing. And then 10 years ago, you have one article that says, yeah, 3D printing warp, ABS warp because of shrinkage, blah, 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 because this is how it is in injection molding. And then since then, people has been using copy, paste, copy, paste, copy, paste until nowadays. And now if you ask people why, nobody knows. Yeah, I'm sure if we go to the root article where that come from, I'm pretty sure it's an article in injection molding for ABS. You see, for example, the 3D printing professors answer the same. ABS was designed to shrink in order to make the mold release easier. Yes, that's injection molding. That's fine. But why the coefficient of thermal expansion has something to do in 3D printing? Okay, so my answer was, but how people know that warping comes from the material shrinking when cooling down? Well, basically what I just said. I mean, the material exits the nozzle in less than 1 second, it already at room temperature, which makes the whole layer at the same temperature as all the other. Then why would the part warp? Usually people answers are material shrinks when cooled down, but that doesn't explain warping. It does when you look it as a whole. Let's use ABS as an example. Okay, so I didn't read that one. I think I went to bed after I write this one. So let me drink a little bit first. Wait, you don't need a heated chamber for ABS? Well, you need, but the Bamboo Lab says you don't need. I mean, they don't say you don't need. The Bamboo Lab says you can print the full volume ABS part on their printer without a heated chamber. I don't have an X1 printer. I don't have the Bamboo Lab, so I cannot confirm, but I'm pretty sure that if you print a big cube in their full build volume in ABS, it's going to warp because they don't have a heated chamber. 100-degree bed heat ups my huge chamber to like 45 degrees. Yeah, it's not enough. It's not enough. I mean, I'm pretty sure you have a big printer and most likely a big build volume. 45 degrees is not enough. 45 degrees is enough for maybe a fist-size print, maybe a little bigger. But if you want to go bigger, then you have to release more stress, because the accumulation of stress for a big part is much more. So if you print a small part, then the stress will accumulate, but maybe not enough to overcome your bed adhesion. So that's fine. But if you're printing a big parts, then it will definitely overcome your bed adhesion or your layer adhesion, one or the other. Does warping happen anywhere else other than the bottom layer? Yeah, it can happen anywhere. You know, it can happen on the bed. It can happen between layers. Yeah, anywhere, at any level, it can warp, because the stress is everywhere. It's gonna warp where it's gonna fail. So if it fail at the bed adhesion fail against warping, then it's gonna warp at the bed. If the layer adhesion fail against warping, then it's gonna delaminate. I believe that all Vorons are like that. I just verify. Is heated chamber the same as enclosed chamber? No, Nathan, it's different. A heated chamber is actively heated. So you set up a temperature, like you set up 60 degrees, and then you will have some blow dryer or like some heater that will heat up the chamber at 60 degrees. An enclosed chamber is you just close it. So usually you can heat up. The enclosed chamber is going to heat up a little bit because of your bed temperature. We usually call this passive heating. Passive heating because the heat comes from the bed. And when you enclose the printer, then you can take advantage of the fact that you have the bed inside. But that usually go to 50, maybe 55 degree maximum with passive heating. But with active heating, then you can go to 80 degree, 100 degree, 120 degree. Most printers use a passive enclosed system, which gets very hot. Well, most printers use a passive enclosed system, which gets very hot. Passive heating usually don't get very hot. I mean, well, it depends what you define by very hot, but 60 degrees for me, it's not very hot. Do you mean active heated chamber? So Bamboo Lab is just enclosed chamber. Yes, Nathan, the Bamboo Lab is just enclosed. So maybe the Bamboo Lab, I guess you can reach maybe 50, 55 degrees C, I guess, inside. If you use a 100-degree bed, then I guess it's going to heat up the environment to around 55. That's my guess. Okay, so what's the next answer from Steve Work? It does when you look at it as a whole. Let's use ABS as an example. Since it's one of the most notorious for warping, it isn't necessarily just that it shrinks when it cools down. That is a bit simplistic. You have to look at both the interaction between the first layer and the bed, as well as each consecutive layers, or even down to each line within a layer being added to the one below it. Yes, the first layer will be at a fairly uniform temperature, theoretically, by the time the next one comes along. I say theoretically because we are assuming there are absolutely no draft in the room or any fluctuation in ambient temperature. And the bed is heated to a perfectly uniform temperature across the entire surface, which very rarely or possibly even never actually happen. Okay. Then as you start extruding more high temperature plastic line by line, that plastic instantly adheres and begins to cool. But since it isn't printing an entire layer at once, like a resin printer, the heat is being distributed unevenly to different parts of the print at different times, cools as it goes, and causes stress unevenly across the print as it continues. Prints with much lighter surface area are affected by this more because it takes longer for each layer to be completed. So there is more uneven thermal reaction taking place. If you throw any part cooling fan into the mix, the problem gets even worse. And to go back to the unevenness of the bed heat, the center of the bed is typically going to measure warmer, which is why outer areas are more prone to warping, Once again, a part cooling fan makes the problem even worse. The geometry of the part also makes a difference. Just from physics, sharp angle are more prone to warp because there is less surface area holding it to the bed than a rounded edge. I think I had some other thoughts when I started typing that, but by the time I managed to type that much on my phone, I forgot what it was. Okay, so first, I really appreciate that this guy is taking time to explain his theory of warping, especially on the phone. But his explanation is logical. There is a couple of things that I think are strange a little bit. That doesn't explain some of the other some of the experiment. But at least I like the explanation. It's clear. It goes down to a little bit more detail. So I like it. I'm not going to dissect it because the issue with the explanation is some stuff that we have highlighted before. But I like it, and it is one of the answers that has made me change a little bit the theory of thermal expansion in order to be a little bit more logical, especially when he was saying about it depend on line by line instead of the layers. But anyway, you are going to see that when I'm going to release my my small paper on thermal expansion, because I already did a paper on elastic shrinkage, and I'm trying to do one on thermal shrinkage. You are going to be able to challenge me a lot on that one because it's not perfect, but hopefully with your help we can make it more perfect, because nobody has challenged me on the other theory, because I think you are less familiar with it. But hopefully you are more familiar with the thermal shrinkage theory, so you will be able to challenge me more on that one to make it better. Okay, so that was for Steve. Thank you, Steve, for participating to the discussion. Next, should be able to hit 60-65 with that small size chamber. Okay, that's yeah. I mean, for me, it's not that hot, but it's better than nothing. I mean, you can print decent polycarbonate and ABS part with 60-65. Hey, Sally Liz, how are you doing? Okay, Bill McDaniel. Warp from the build plate depends on the material. Okay, so yes, I'm trying to understand why a part would warp from the build plate when printing. Are you having a specific problem with a specific filament? Okay, well, I didn't answer. Yes, I am having warping issues with ABS on N3. Okay, so I don't know how this will help him with the explanation, but at least he has all the information. Kenobi. Okay, so let's see what Obi-Wan has to say. Shrinkage due to uneven temperature from draft, erratic cooling, and so on. So why would the material warp more? Okay, so my question is, why would a material warp more than another? For example, why would PC warps more than PLA? Okay, due to material properties. Some reason why water-based paint dry faster than oil paint. Okay, so basically, but what properties? Like I said, I did some research and the answer is always the same. Some materials warp more than other because this is how it is, right? Because basically the answer is some material warp more than other because they're different, okay? And then he copy paste the link of CNC Kitchen why 3D print warps, but again, this might be the worst video in terms of 3D printing explanation. The only thing I like about that video is the only experiment that shows elastic shrinkage. I mean, we checked that video together, right? And we dissected that video together, right? Georgie, well, that's okay. Another guy is trying to explain. It's all down to molecular structure. That's an easy answer. If you are not good at physics, you will not understand the hard one. But if you want or learn, you can start here. Okay, so apparently he's linking me to some thermal experiment. Okay. So basically he's trying to explain to me what is thermal expansion? Yeah, I guess it's a start. But then my answer is going to be the same as all the other answer. Why nylon and PC warps more than PLA if nylon and PC has the same, if not lower, coefficient of thermal expansion than PLA? Because it's always the same. Everyone is saying the same, but nobody has asked why. Like this guy is trying to explain to me what is thermal expansion. But if you look at it, then just if you think it's about thermal expansion, at least check the thermal expansion of all the different materials and try to find any correlation. If you plot the thermal expansion of all the different polymers in 3D printing, and then you rate the warping behavior of each of them with your experience, then you are not going to see any correlation between CTE and a warping index. I mean, that must be something that we need to think about, right? Well, I see this, so I'm already thinking about thermal expansion because this is, the bridge thing. So I guess they are answering the same, just the property. Okay, that's the simplest and more. Oh yeah, I really like his explanation. It's very simple, but it's explained very well. You lay down a layer and it shrinks, and this is a good summary of what people think. You lay down a layer and it shrinks as it cools from the nozzle temperature. You bind the next layer on top of the cooler layer and it tries to shrink as it cools. This puts some compressive stresses on the lower layers and they bow up. As you stack more and more layers, it gets harder and harder for the compressive force of a single cooling layer to cause additional warping. Okay, so that's the best answer I have seen out there that explain the common thinking about warping, okay, which is the thing I'm challenging. So that's what I'm saying. That's the simplest and most understandable answer I got so far. Thank you for sharing. Quick follow-up question. How would you explain that some material warps more than other? Just the properties of the material. Steel expand more than titanium under heat because it has a higher thermal expansion coefficient. PLA and PETG equally have different properties. If you want some light reading, okay, so he is pointing me to a Wikipedia page of thermal expansion. So again, he is saying this. You know what I should do? I should have a graph, okay, and then on one side I should have the thermal, the CTE of all the polymers, and on the x-axis, and on the y-axis I should have the warping index of all the different materials. And then every time someone would answer me the thermal expansion, then I would just put the graph. And then I would just ask, okay, explain me this then. Why? Yeah, I need that graph. You know what? I'm going to do that graph. I think I'm going to do that graph. That's the easiest way to, like some kind of graph like this with like, we have like ABS and then PLA and then PETG. And then basically you have, you know what? How can we, let me check. How can we draw? I want to make a small infographic that can show people why I don't understand the thermal expansion theory. Or at least a small infographic that shows that the thermal expansion theory needs some working, right? So if you get that, let's put it in the best color there. Okay, and then I'm just thinking about a graph. So if you have something like this, right, and then you have like I don't know, thermal expansion, something like this, and then some kind of warping index. So warping index would be just from our experience, like we know ABS warp more than PLA, blah blah. So then we'd have something like we just put like an XY chart. We just have like a cross that we put inside. Let's take that one, and then we'll just put this inside. Okay, and then let's put that like this. So we would have, for example, ABS would have high thermal expansion. Sorry, so the CTE would have a high CTE, right? And a high warping index, right? And then we would have PLA with let's say a regular CTE, let's say a normal CTE, and then a low warping index, and then PC that basically have the same warping CTE and much more warping index, actually more than ABS, slightly more than ABS. And then would have PTG that has a slightly lower, let me know if I'm wrong, but I think PTG has a slightly lower CTE, but warp a little bit more. And then you have, I think you have then, you have PVB, PVB, PVB. What's the CTE of PVB? So it's around 2.2, Kelvin 10.4, and then the PLA was how much? The PLA was okay. So it's higher, right? So it's higher, but it warp. Is it as much as ABS? ABS was what? A little bit lower than ABS. Yeah, I didn't check properly, but maybe I'm wrong. But something like this. And then what? Then nylon. I think nylon is also, I think, lower than PLA, if I remember well, or pretty much the same or lower than PLA, or at least the PS6 PS66 compound. Something like this. Well, anyway, we can get the real data, right? My graph here may be wrong, but if you have something like this, then how can you make a correlation between CTE and the warping index? There's no correlation, or there is something else that has to be explained. Maybe this is CTE below TG, and maybe you have to do a CTE above TG, and maybe above TG has something, or blah blah blah. So there's something, because if you have that graph and you have something like this, if you show me something like this, I mean, approximately, right? Like if you have a graph that is something like this, then yeah, maybe I would say, oh, it seems that there is a correlation between the warping index and the CTE. Then I would agree. But in that case, no, I don't understand. There might be two type of maybe high warping stuff and low warping stuff. It seems that there is nothing in the middle. But yeah, you get what I mean? I was putting my printer back together here to learn. Peslis, if you're looking to learn some hardware stuff on my stream, it's not the right stream. You better go on the Nero 3D stream because my stream, the hardware knowledge is -3. Good night, everyone. Good stream. Sorry, I was not active in chat. Was just lurking tonight while working from the bed. Hey, good night, Cadence. Hey, Subsector 3D, is that you? Filament blockade, but it was the printer, not the filament. Oh, okay. To be fair, you would have to factor in print temperature too. In addition to coefficient of thermal expansion, in other words, it would be cooling further. Kevin Tucker, that's fine. Let's just consider that you print all of them at the same temperature. Hello, do you know the answer? I don't, just curious now. What answer are you looking for? Are you asking me where warping come from? If I know this answer, I know one answer, which I I shared a lot already. The elastic shrinkage theory. That's my answer. But yeah, depending on what question you are talking about. So the CTE would be applying over a large temperature differential. Kevin Tucker, the CTE is pretty high for polymers, so even a small temperature difference is already a big shrinkage. So, but yeah, the higher the difference and the more it would shrink. Love the art drawing, Nick. Do you like my PPT skill, art match animation? I think you need to multiply by the temperature drop to give the theory a fair shake. Kevin Tucker, like I said, let's just imagine that you all print at the same temperature. Let's print all of them at 260 degrees. Because that doesn't affect the theory, right? Because they can all be printed at 260 degrees. So if we all print at 260 degrees and some has a higher CTE than other, then they should shrink more. But Nick, we are hero for the hardware part. Oh, we are here. Sorry, my screen quality is not that good, and then we are here. Yeah, exactly. I'm here to help on the material part. You guys are here to help on the rest: software, firmware, hardware, electronics. So I'm only I'm only material. Does anyone print these at the same temperature though? But that doesn't matter whether people are printing at the same temperature or not. I think it's just yeah. I don't think it matters too much to for the theory. Where is PA12 in that graph? Yeah, Francis, I don't know all the CTE, so but I did share I did share something with all the CTE, I think. Here you have all the CTE here, and then you have the different CTE, whether it's above TG or below TG, blah blah blah. But I don't think, do they have PA12? Yeah, PA12. So 9 to 15. 9 to 15. Let's check what is close to that. The ABS was also 15. Let's check compared to some other. PS666, 5 to 12, 5 to 14. PC polycarbonate 7 to 9, so that was on the low end. PETG 8 to 8, okay, so that was on the low end as well. PLA 85 to 85, yeah, so PETG is lower than PLA, and the PA12 then would be on the higher end. So PA12 would be PA12 would be somewhere here, I guess. Again, just a guess. I mean, a really rough guess. So PTG, yes, PTG is lower. PP, PP has a pretty low. Let me check. PP, well, low and high. Okay, what's the max value? Yeah, PP is a little bit all over the place. Oh no. So not PP impact modifier, homopolymer. Yeah, okay. What else do we have here? Yeah, that's it, more or less. But I can try to draw a graph with our material. You know, our coefficient of thermal expansion, and then our stuff. That might be easier. Okay, so that was for Prusa. Next is the 3D printing geeks. So hopefully they are geek enough, you know, like to really get into really get into that. Well, I only had two answers, but let's see what they are about. It matters only that people experience with how much this material warp is based on printing at different temperature. Yeah. Yeah, it matters when we will try to solve the problem. Maybe higher temperature is better than lower temperature, or maybe temperature doesn't, like the other people say. They say that the printing temperature doesn't matter on whether the part is going to warp or not. The only thing that matters is TG. So PC is more warping than ABS. In my experience, slightly, depending on what ABS you are using. They're at a similar level, but it depends what PC. Like if you're talking about Polymax PC, then maybe similar level, if not a little bit lower. If you are talking about high temperature PC, then it would be something like this. Okay, so it depends on the PC you're talking about. But generally, regular PC is something like this. The Polymaker PC is something like this. That's how it is. So I warp like PA6. Well, for the warping, I don't know, Francis, because our nylon are warp-free nylon. So I never had warping issue with nylon. So I just put it there. I just put it at the high warping index because I know people has a lot of warping issue with nylon. But I personally never had any warping issue with nylon because of the nylon we design. So I have no ideas what people experience between PA12 and PA6. So you would have to tell me if you have experience. But if you are printing with Polymaker nylon, then you also don't have experience with nylon warping, I assume. So I have no idea whether they are on the same level or whether they are more or lower. I have no idea. Okay, so 3D printing geeks. What did I ask? If warping is because of the part cooling unevenly, then why cooling the part faster would not help reduce warping? So let's find out. It's all about striking a balance. If it cools too slow, you can see elephant foot happening. If it cools too fast, this can happen. All layers might not adhere. Plus, we could be using the same filament, the same temperature. Okay, so he's talking about elephant foot. I think it was my mistake. Before I use a different picture, and there is a little bit of warping, but there is an elephant foot, and most likely he didn't read the question, so he jumped directly on what he have seen on the question, on the picture, and it was about, yeah, so he didn't read the question, so let's just skip that one. Okay, what is this one? Where is my, there is one that there is very funny. Oh, is this one? Is this one? Oh, it's the last one. Okay. So the last one is very funny. But let's finish this one first. I just got my Bamboo Lab survey to get my printer. Oh, great. The Kickstarter finished at 8 million, right? 8 million. So I guess they will start shipping soon, I guess. Polymer chain crystallization generally cause contraction in thermal. Oh, I remember that. Okay, so check this properly. When I was talking about some people that, talk about, some polymer stuff, and then some other people are reading, and if it's not very true, then, that brings a lot of wrong information. So check this. Polymer chain crystallization generally causes contraction in thermoplastic. If you accelerate crystallization locally with cooling, the area will be under greater internal tension than the rest of the object. So it will shrink more relative to a less cooled area. As the overcooled area contracts, it will pull on the polymer chain around it, which is typically described as warping in FDM. Okay, so my answer. But fast cooling does the exact opposite. It will prevent the part from crystallizing. Also, how about amorphous material like ABS, PC, and PETG? Why would they warp when using cooling fan? because they don't crystallize, right? The amorphous material. Faster cooling means faster crystallization and more extreme warping. So you can see that there's already something strange. I mean, crystallization, faster cooling is the exact opposite. It prevents from crystallizing. But anyway, you're going to realize that what he means by crystallization is completely different, actually. Slow, steady cooling would be the best to prevent warp, but your bed adhesion needs to be good enough that it doesn't peel off and start warping before the whole part gets down to temperature. So that's another thing. There's a lot of people that, they go like this. For me, what we should do is we go from the experiment, and the hypothesis needs to be a strong theory that explain the experiment. But in many cases, people are taking the experiment and making the science being like shape the science so that they explain the experiment. I don't know if that makes sense, but I think they're taking it the other way around. Like, for example, some people see that the warping goes upward, right? We all talk about shrinking horizontally, but why is it shrinking vertically? And then you have a lot of people that think that shrinkage happen vertically, like it's shrinking like this. Like, for example, the 3D printing professor explanation was this. Do you remember when we checked his video? It was the layers are shrinking horizontally, not vertically. Vertically, not horizontally. But anyway, let's finish that. Well, I need to drink more, but I don't have water anymore. Let's finish that explanation. Wait, because I was completely lost. Slow and steady cooling is how we crystallize polymer. I think there is some misunderstanding somewhere. Crystallization is the process that is time dependent. Crystal grow over time. So you need to leave the polymer at the crystallization temperature long enough to fully crystallize. If you cool it down too fast, then it doesn't have time to crystallize. For example, you can anneal PLA to crystallize it, put it in the oven at a certain temperature for a certain amount of time. So I wanted to clarify what crystallize means, because we were thinking completely opposite stuff. And then I realized why we were thinking differently. Fast cooling is ideal for certain polymers and geometry if it can be done equally throughout the part throughout the printing process to preserve steadier geometry. But that's from Michael, so that's a different one. Deal with temperature shock going from extrusion to, yeah. So this is also about thermal shrinkage and blah blah blah. So not very interesting. The same thing as others. So the answer from Sam, so the same guy that we were talking about crystallization, his answer was no. Crystallization is not the same thing as crystallization of polymers. Basically, the plastic is just going from a molten to a solid state, and the molecular chain of the polymer freeze in place. So that's why we have some misunderstanding, because I don't think he's using the right vocabulary. Like he thinks that crystallization and crystallization are different. Crystallization and crystallization of polymers are different. So what I answer is, I don't think there is such thing as crystallization of polymers being different from crystallization. I think you are talking about the transition between the rubber state and the glassy state. Because in polymer, you also don't have transition from molten to solid state. You actually don't even have a melting temperature for most of the polymer in 3D printing. But after, I didn't have any answer. So that means usually either he didn't have time to answer, either we reach the limitation. But you can see that, he's very certain about what he's saying about the crystallization going from molten to solid state and the polymer will freeze. And my worry is that, more people are going to see that, and more people are going to build that knowledge on maybe a not good, not good knowledge, or not a great place to start. Anyway, you shouldn't start by learning on Facebook first. But you get what I mean. People are going to read this, and then people are going to copy paste. They are going to see that, and then in another group, someone is going to ask about warping issue, and then the guy is going to say, yeah, it's because the polymer are crystallizing, and then when they cool down, then they crystallize to a solid state, blah blah blah. And then copy paste, and then all the Facebook group will talk about the same thing. So that's why we need more print busters in this group. We need more representation of print busters. Okay, now the best one, 3D Printing Canada. Hi, Nicola. Too funny. I didn't realize these posts were to create discussion for stream. I think setting a challenge for Stefan is a great idea. Hey, Matt. Are you there from the beginning of the stream? Actually, we saw some of your answers, but obviously we didn't spend too much time on these answers because it was the same as my answer. But thank you for joining the stream. Remember, guys, Matt Tyson is our Discord polymaker expert. It's the only polymaker expert on Discord at the moment. A really, really knowledgeable guy from Australia. If there's anyone that needs material, by the way, is there anyone based in Australia? Except Matt. Is there anyone from Australia? Most likely, if you are from Australia and you print polymaker filament, most likely you get them from 3D printing solution. Crystallize is like when quartz form crystals because slow cooling during solidification. Yes, non-fam. Yes. No, I joined about 10 minutes ago, but I skipped through and saw the Australia post. Okay, got it. Okay, so let's check the Canada. So my question was the same. I know it's a difficult question, and I have done my research, but I cannot find anywhere good explanation of blah, blah, blah. So if you have any idea, blah, blah, blah. Okay. Ronald. Okay, here is an example. Why does water expand when it becomes ice? If you know that, then you should understand why some plastic warp all about expansion when items get cold. So like everyone has said, if the item cools too fast, it will expand and shrink. This is why all has to do with chemicals in plastic, and all of them work differently. And no two are the same. Simple as that. Also, why is this so important? You are going to see these answers here are very funny. I mean, first, he is just copy pasting the same thing as every other. Warping is because material are shrinking and expanding, shrinking and expanding. Why? I have no ideas, but why is it important, right? Why do you care? That's everyone say that, so let's go with it. So that's the type of answer that I don't think is very useful for 3D printing science. Or at least it's not going to bring printing science more than where we are now. Okay, so let's just go next. All materials contracts when they cool. Every time an answer starts by this, I have a bad feeling. I have the bad feeling about it. I rarely have a following up, a good follow-up answers when something starts by this. All materials contract when they cool and must contract when they change from liquid to solid. If a part is a uniform shape, by the way, I don't think there is such thing as liquid and solid in polymer. If a part is a uniform shape, for example, a circle, the shrinkage will be uniform. But if there are non-uniform shape and thicknesses, which is almost always the case, the shrinkage will be non-uniform and the part will warp. So, does that mean that if you print a cylinder, okay, if you print a cylinder in ABS, it cannot warp because it's uniform? Do you think so? I mean, that's That's easy to test, right? Print a cylinder in ABS and don't use a heated chamber, don't use a heated bed, use a cooling fan. Don't worry, it's not going to work because it's even. I doubt. I think it's going to work. The reason for an enclosed print chamber is to try to make the entire build the same temperature so that the finished part will cool at the same time. Otherwise, bottom layers will cool before higher layers and distortion will be high. Heated build plates are an attempt to counteract this, and they're somewhat effective but not great. Yeah, again, something that we talked about this before. How would you explain that some materials warps more than other? Different materials have different rate of thermal expansion contraction. Okay, that's usually the answer of that. And then I will usually follow up with, now we have a graph. I will usually follow up with the graph. But anyway, each material will shrink at its own rate. The material properties is known as coefficient of thermal expansion, CTE. For example, aluminum has a higher CTE than steel, blah, blah, blah. So you know already what I'm going to ask, right? But PC has the same coefficient of thermal expansion as PLA, and PC warps more than PLA, PC, blah, blah, blah. How can this explain? I think nylon and PTG also has a lower CTE than PLA, but they warp more, okay? So in that case, I'm unsure, but I suspect that it has to do with the shrinkage at the phase change. And this is interesting, okay? This is another thing that I recorded. Do you remember I told you there's two things that has brought, how to say, there's two interesting things that has helped me understand better is the first big comment that we reviewed together and this one. You know, the phase change, because there is indeed some stuff happening during the phase change between the rubbery state and the glassy stage. So there is some stuff happening at TG. I did look a little bit into that, but I didn't find anything interesting when it comes to contraction, when it comes to shrinkage. But the fact that he's bringing that more, you know, makes me think, okay, maybe I should dig that a little bit more. Maybe there is some stuff into that. So I'm going to dig that a little bit more. I'm going to dig that phase change if there is some stuff. The only thing is all polymer has the same phase change, but maybe PC during the phase change, PC, ABS or nylon, maybe they have something that PLA don't have. You get what I mean? So that's an interesting part. And that's why I like to do to print bust a little bit on the different group to find some out of the box thinking. Most materials shrink at the phase change. This is true for most material that has a phase change, like liquid to solid or liquid to gas or sublimation, right? Solid to gas. So this, yes, but for polymers, I don't think so. I don't think there is this, but that's something we need to look at. Blah 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 blah. Calling blah, blah. Why is it hard to understand that every material in the world has different properties? It is not just about the coefficient of thermal expansion. That's just one property. There is different glass solution temperature, heat distortion temperature. You are not considering differences of forces on the molecular level. Let me pick an extreme example to illustrate the type of question you are asking. Why don't apples and oranges taste the same? They both contain similar amount of water. They both have similar amount of sugar. On paper, they should taste identical, but they don't. Okay, so that's the kind of people that basically say, you know, some material warp more than other because they are different. You know, they are different. We don't care where that comes from. It's just they are different. And then his answer is like, you know, my question is the same as apple to orange taste the same. Why they taste the same? Why they don't taste the same? Which is fair. I think I do ask a difficult question, but I think his answer doesn't bring anything to the table. Yeah, they warp differently because they are different. Okay, but how does that help? So here's my answer. My answer is, thank you, but that answer is the same as what I found during my research. different material warps differently because this is how it is. They are different. Unfortunately, it doesn't really help me to understand. Oh, and fruits produce a range of volatile compounds that makes up their characteristic aromas and contribute to their flavor. Fruits' volatile compounds are mainly comprised of ester, alcohol, aldehyde, ketone, lactone, terpene, blah, blah, blah. Apple and oranges have different volatile compounds which give them different flavors. And then I link a paper that shows the volatile contents of apple and the volatile compound of orange. So yes, it's easy to explain why apple and orange taste the same. And I give him an answer. I give him an actual answer and some papers to read. I mean, one of the papers is in Korean, but the abstract and the tables and the graph are in English. So that's fine. It's not because the question is difficult that you have to answer. That's how it is. No, if the question is difficult, then and you cannot answer, then don't answer, or try your best to answer. But don't say that. Oh, but your question is too hard. Why do you even expect an answer? No. If you are asking me why don't apple and orange taste the same, do you want to know what I did? Very easy. If I have this type of question, I go on Google. The first thing I type is why fruits has flavors. Okay, that's what I did yesterday. And then the first answer is because of the volatile the compound. Okay, because of this volatile compound. That's what get it our nose, in our tongue and something. I mean, I went into a rabbit hole here, but the short answer is because of this. So the next step is what's the volatile compound of apple, and what's the volatile compound of orange, and then you compare them. They're different. Yeah, they're different. So they are going to. So the taste is different. The taste is defined by the volatile compound. So you can answer. It's not because something is hard that you cannot answer. So in 3D printing, the warping is the same. It's a hard answer. Then why nobody is trying to answer that? Why everybody is just, it's just how it is. It's different. But then I went to bed, so I don't know what he answered. Yes, way to watch the point being made sail right over your head. The evidence to understand this right before your eyes, open them up. Yes, way to watch the point being made sail right over your head. The evidence to understand this is right before your eyes, open them up. Okay, so I don't understand what he means, but I guess he means that I don't know what he means actually. Is it like the warping is so easy to understand? It's just that I don't open my eyes enough to see. I don't know, but for me, he's, it doesn't help very much to say that it's a hard question and different material warp differently because they're different. And then after that, just saying that, I'm not understanding the point and I don't open my eyes. Then just explain to me. I did spend time researching why apple are different from oranges. So, at least, spend some time trying to answer my question if it's that simple. Okay, the next one is he's saying he missed the point, even though it was clearly stated. Oh, he missed the point? Yes. Way to watch the point being made sail right over your head. The evidence to understand this is right before your eyes. He's saying he missed the point. I think he's saying I missed the point, no? Even though it was clearly stated. I passed because of budget, not because of lack of interest. Used a lot in if someone misses a punchline. And that response got some thumbs up too. Quite sad. ABS and PLA should test differently too, I guess. Yeah, Nathan, I guess so. But anyway, that's, in many Facebook group, you have many people that are a little bit like this. Once you try to dig up a little bit an explanation, you get kicked out. You don't get kicked out of the group, but people just get angry. Sometimes they get angry because you are asking why. But to be serious, they're really, I mean, one day I will show you some discussion that I had. It's like they get crazy when you try to understand a little bit more, and it's a pity. It's a pity that people are afraid of knowledge. They're afraid of. I don't know if they're afraid of not knowing, because I know it's hard to not know something, but sometimes you cannot know everything, and it's fine. It doesn't matter. But they're afraid of not having answers, and I think that's the thing that makes them frustrated and maybe answer off-topic question, off-topic answers. The next one, temperature differential, same thing that cause warpage when welding. That's the second thing. There's a lot of people that pointed me to welding, so I did some research in welding. I haven't finished yet. I'm still learning. I haven't picked any interest in the articles I found. I want to find something that really explain the things well and stuff. I know the Maker Muse-Right is into that industry. So I know if I have question, then I can just ask him. But I want to make my homework on my own first. But a lot of people has pointed me towards welding as a reference for warping. When you heat up something, it cools off and contracts. Okay, I mean, at this point, this sentence is like, is I don't know how to say, but I see this sentence every time I talk about warping. When a material cools down, then you shrink. You know that, so, or when that material expand and shrink with the temperature. So, yeah, I know. What's the point? What's the relationship? That's what I'm looking for. But anyway, I know you need to start somewhere, and usually people start by this, which is fine. It's just funny that I've been so much into warping that it start, having this answer all the time start to get to my head. Best thing to do is to set up an enclosure, blah 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 blah. So it's copy paste. I have warping issue. Yeah, warping come from material shrinking, expanding with the temperature. So use an enclosure and a heated bed. Got it. So why PC polycarbonate and ABS warps more than PLA? One features of ABS is by design. It shrinks when it cools. This was designed. Yeah, that's why I don't use the word ABS, because ABS is also a copy paste. Every time people see ABS warps, and then they think about injection molding, shrinkage, and then they copy paste. So that's why, if you notice, I always use PC and PLA. I never use ABS. And you see, the one time I use ABS, the only answer they give me is because ABS injection molding. They don't even talk about PC. And that's the thing, is because people copy paste. I mean, it's fine to copy paste if you understand, but don't copy paste if you don't understand. The makeup of the material science stuff, some materials are high risk of warping a lot more than others. It's the same thing with welding, blah, blah, blah. Stainless, for example, warp like crazy, blah, blah. So that's the same answer. Some material warps, some doesn't warp. We don't know why, but that's how it is. I'm sure people do. It's just more of a material science thing, so metallurgy, blah, blah. I agree that any deeper answer will likely come from materials textbooks that talks about different way molecule bounce. No, I also did some research in material science, and no, I mean, 3D printing is too early to have great papers on that, because everyone thinks, yeah, we don't have to care about it, because I'm sure some material scientists, or I'm sure the filament manufacturers, they know where warping come from. Just ask them. But we don't know. We don't know. And even material scientists, they don't know. Or maybe there is some material scientists in the world that they know. But please put it on a paper and share with the world, because we want to know. Taking several materials engineering course in university would be a start. in the right direction for truly understand the why. Sometimes these courses are further broken down into solid, fluids, material, chemistry stream. Maybe if you have a little bit more polymer science background, maybe you can start to have some logic. But again, why there is nothing on Google? Why there is nothing on the internet? If it's so easy to find, to just find some courses. Uh, 11 people. Problem is people you are talking to are more interested in practical explanation that allows them to fix their immediate printing problems, not an in-depth scientific explanation, and are used to talking to people with the same problem that they're trying to fix. Yeah, Incendium. This I agree. That's why when I feel that, they are not really in the same in the same line of thinking, which is trying to understand more. If they are more towards, they want the last word on how to fix it, I don't know how to say, but I can feel sometimes when people are towards a constructive discussion, or when people are towards closing a discussion as close as possible, as fast as possible. So I completely agree, Incendium. From what I know, stainless warp more because of its low thermal conductivity, so the heat stay more localized. Okay. Yeah, I do need to look into the thermal conductivity stuff. We can make a graph like this, thermal conductivity of the different polymers and the warping index, and then see how it looks like. Maybe we'll see something. Hey, my German. Hey, my German, are you free today? Are you free today for a small talk on the lithopan? I'm free. I'm free the whole day. I mean, after the stream, I have one meeting, but then I'm free the whole day. But I don't remember which time zone you are. I have done work with glass fuzzing, different type of glass shrink, different amount, and cooling, and will warp and pull apart. I have done work with glass fuzzing. Sorry, I don't know what is glass fuzzing. Glass fuzzing. Glass fuzzing. Okay, well, that's cool. But so what is it? Glass fuzzing. Meaning? Fuzzing is the technique of joining two or more pieces of glass by heat in a kiln. Oh, okay, got it. So what were you saying? I have done some work with glass fuzzing, different type of glass shrink, different amount on cooling, and will warp and pull apart. Oh, okay. Yeah, I guess that's the problem you may have when you join two parts together that may not have Yeah, I guess I could understand why you would have similar issue with glass. Oh, fuzzing. Oh, okay, fuzzing. Yeah, with glass fuzzing. Fusing. Okay. Oh, fusing. Okay. It's midnight for me. I'm heading to a great conversation tonight. Thank you, Dazinzia, for joining the stream. Thank you very much. It's already 3 hours? Oh my God. Hey guys, check your clock. It's already 3 hours that we've been talking. Oh, that was, I think today's stream is one of the most lightning stream I've done, to be honest. I mean, usually I look at the clock, it's already 1 hour, 1 hour 30, and I kind of thought it was half an hour or something. I thought it would be, I knew it was a long stream, but I was expecting like around 1 hour. Well, we are closing on 3 hours right now. Well, it means that was a very passionate stream. I think we've been very I hope we've been really into that. I've been really into that, but I hope you've been into that as well. Yeah, awesome. Maybe because I missed last stream, so I'm kind of catching up now. I want to talk about 3D printing. The problem you get into with polymers and their properties is it's mostly trade secrets, and I don't find a lot on Google. Slim picking. I don't know how much the formula would impact. I mean, I don't know. I mean, I also have access to the formula, but it doesn't. I don't know. I don't feel that it matters too much. When they get defensive, when ask a question that challenges what they know. Yeah, incendiary. Yes. Usually, I usually stop the discussion when they get in the defensive mode, because that means we won't learn more. So I just stop. Matt German, yes, okay. So how about we do that, Matt German? How about we jump on Discord after the stream, if that's okay for you? I mean, like maybe 20 minutes or something, just for you to give me the feedback on the lithopan, so that thank you, by the way, for helping us designing that material. I will send you some rolls as well. Send me a roll of PC and I'll do some warping test and try to better predict how a print could warp and why. Francis Bellon, you can come on our Discord. We can discuss that on the Discord, on the warping server. If you have some test, you can tell me the test you have in mind and explain me, the logic. And then if we find that it's a great test, then definitely I can sponsor some materials for that. 3 hours new record. Yeah, 3 hours. That's crazy. I mean, I've done longer stream, especially on Twitch on Saturday. Like, I think the longest was 4 hours. But it's the first time I do such a long stream without realizing it. 9 p.m. is Las Vegas. Yeah, it goes fast. So 2 rolls of filament. I work in an industry with rubber chemists and have some friends trying to model rubber viscoelastic and aging properties. Even they are convinced it's dark magic. Yeah. I mean, Incendium polymers, the polymer science is still very, very unknown. The polymer science is very new, extremely new for a human, for us. There's so much going on. Even our CEO, material scientist, PhD material scientist in polymers, he told me that the science in polymers, it's at the very beginning. There is still so much thing that we don't know about polymers. So I mean, we are PRINTBUSTERS is tackling something hard. I'm not gonna lie. You guys have taken a very hard train here. But anyway, the last thing I wanted to check is I have asked people if they have any papers or something to read. Then we can have a look at this quickly. There is not a lot of links. I think there's only one link, and then I think we'll stop the stream, because it's already been 3 hours and it looks like most of you is pretty late where you are. Yeah, 11 p.m. in Houston, midnight, I guess, East Coast. 9 p.m. is Las Vegas. I guess it's Pacific time, I guess. So let's finish. Let's finish soon. So let's look at the answer. Honestly, I would think rapid cooling of the filament laid down. Blah blah blah. Can't wait to see the findings. So you see now more and more people are waiting for PRINTBUSTERS to release their papers. So you need to help me, guys. You need to jump on Discord, on the warping, and then you need to get, you need to write some stuff. You need to write your ideas, your explanation, because it's not easy to write the papers with all of this. Obviously, the paper will be dynamic. It will change over time, but I need your help, because people are expecting a lot now from PRINTBUSTERS. They are expecting knowledge from PRINTBUSTERS, from our community. I look at the phenomenon as being quite similar to warping in welding, maybe the direction. I've noticed that warping becomes almost a non-issue for me if I use absolute lowest temperature, blah, blah. I know in thermoplastic there is, this is sort of undesirable, but lowest melting, quickest freezing and low heat, blah, blah, blah. Okay, so we've seen that before. Search cold water immersion plus human male. What? Search cold water immersion plus human male. Okay. Can't wait to see how this turns out. You guys are really trying to take the science of printing to the next level. I appreciate that you're trying to improve your product when everyone else seems to just assume thermal expansion contraction is the cause. Air conditioning heating the build plate does it for me, blah, blah, blah. I have never have warping in my heated chamber, blah, blah, okay. I have no evidence other than my personal experience, blah, blah, blah. Okay, so we only have one link, which is this one. This is from Hubs Protolabs company. I don't know this company. What is FDM, blah, blah. Okay, so is there a difference between blah, blah? What are the characteristics, common materials, post-processing? Okay, are they even talking about warping here? Warp. Okay, warping. Warping is one of the most common defects in FDM. When extruded material cools during solidification, its dimension decrease. Since different sections of the printing part cooled at different rate, their dimensions also change at different speed. Differential cooling causes the buildup of internal stress that pulls the underlying layer upwards, cause it to warp. There are several ways to prevent warping. One method is closely monitor the temperature. Okay, so yeah, that doesn't. Every material has its own substrate. For instance, ABS is generally more sensitive to warping than PLA or PETG. Sharp corners warp more often. Thin okay, so yeah, doesn't help very much. You know, at some point we are so much into, it that, it's very hard to find a papers that would explain more than what you already know. So the next step is really us doing the research. Okay. Do you need caps? He's talking about blood vessel constricting in the cold. Oh, okay. He meant that human male have shanking too when exposed to cold water. Okay. 9 people hit summer bottom, please. Thank you, Robert. Okay, guys. So what did you think about today's stream? So I hope it was useful for most of you. I hope it was a great discussion. Please, if you do print bust in some forums like Loosebot forum, Prusa forum, Zilchimaker forum, Reddit, Facebook, on Twitter, wherever you are print busting, and if take some picture and share it on Discord. So you go on Discord, and then there is PrintBuster General, and I want to see a lot of screenshot of our community print busting everywhere. Print busting means asking why, challenging people, bringing some science to a forum, explaining some stuff that you have learned on PrintBusters, sharing your science about 3D printing, all of this. I want to see more sharing. Of course, print busting is one part. Of course, it's about challenging people, bringing the science further. But on the other side, don't forget that it's also about sharing our discovery. Okay, so if you see that some people are stuck somewhere, go there and share about what you have learned. Like share about what you have learned about the different thermal properties of a material, the difference between different TG of a material, the difference between the flow calibration that we talked about, the wet filament, what is happening during wet filament, blah 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 blah. Okay, and then take some screenshot when you have some nice discussion about print busters, and then it ending up in a funny way or something like this. Take some screenshot and share it on PrintBuster General here, and let's start to print bust a little bit more outside the PrintBuster stream. And that would be awesome. And I know you guys are awesome. I mean, every stream you guys are repeating that you are awesome in my stream. So I know you guys are awesome. So let's do that. Trolling people on Facebook. It's not, I know a lot of people would consider trolling people, but I wouldn't say that. It is trolling people if if people are close-minded, then it looks like a troll because they are close-minded. But if they are not close-minded, then they are going to consider that as someone is looking to understand, and I want to help him to understand. And then this someone is engaging some very interesting discussion. He's asking some good question. That's a good print bust. A bad print bust is you ask a question and then the guy is like, hey, why are you trying to understand this? You are wasting my time, something. If that's the case, you can also take a screenshot. I want to see if there is more people that are close-minded to people that are trying to learn more, or is there more people that are trying to help sharing their hypotheses and trying to, be more open-minded when someone is trying to look deeper than the average? FDAF patch. I'm gonna look at this. You can definitely join. Again. If you won many times, then it means I don't know. Your name is Mark. That's why. Okay, you guys ready? We are going to draw in 5. Is there anyone? 46 people and then 34 watching. So I guess we have everyone. So we are going to draw in 5, 3, 4, 2, 1. Drawing. And the winner is going to be Mark Andraka. I'm sure it's going to be Mark Andraka. Oh, Michael Wingington. Oh, I think it's not the first time. I think I remember your name. Is that the first time or is not the first time? Are you here? Michael. Is that the new era? After the Marks, now it's the Michaels. Are you here? I give you 10 seconds, Michael. 10, 9, 8, 7, 6. Yes, you're here. Great. Second time, yeah. I was wondering the same. So congratulations, Michael Winnington, for winning a spool of polemical filament. So if it's the second time, you most likely know what to do. But do I have bank contact on YouTube? No, I don't have. This is only on Twitch. So here's my email. Sorry, I don't have comment on YouTube. Here's my email. Contact me on Discord or email or wherever is the best for you. Okay. So guys, it was a fun stream. Thank you again, everyone, for joining. Don't forget to print bust more outside Twitter, Reddit, Facebook. Print bust more and more. Bring some science. Share what you have learned and push people to think more about 3D printing. The more we'll have people thinking deeper of 3D printing, and the more we will develop the knowledge of 3D printing science. So have a good evening for most of you. Have a good day for the rest of you. And then I will see you. Tomorrow for me on Twitch, on Saturday Twitch for the hangout, and then we'll have a lot of new stuff tomorrow to talk about. Usually during the hangout we discover some new technology that I found out during the week, or some 3D printing news, or sometimes some new products, stuff like this. So it's also quite nice to join us on Twitch. So I will see you guys on Saturday, next Tuesday, or just next PRINTBUSTERS. Thank you again for joining, and have a good one, everyone.